Beneath the perpetual twilight of the southernmost skies, where winds echo like a caution through silence older than time, lies a realm few have witnessed and fewer genuinely comprehend. Antarctica, a continent shrouded in ice and enigma. Initially, it appears merely a frozen expanse, yet looking closer reveals something far more peculiar. Buried beneath layers of ancient ice lie anomalies defying explanation. Perfectly geometric configurations hidden in satellite scans. Fossils of tropical flora where warmth has been absent for millennia. Undetected metallic objects deep below the surface, predating human civilization. And unsettling magnetic disruptions extending across the landmass with no apparent origin. Some attribute this to natural geological processes. Others murmur about lost civilizations, clandestine experiments, or remnants never intended for discovery. What secrets does Antarctica truly conceal beneath its frozen stillness? And why are certain findings quietly disregarded, forgotten before they are truly understood? So, find comfort, unwind, and let us delve into the icebound mysteries of the last true frontier, where scientific inquiry meets secrecy, and the Earth itself keeps its most ancient secrets buried in the cold. In the core of East Antarctica, where perpetual icy winds sweep over a bleak white panorama, lies a territory known as Wilkes Land. It is a remote, inhospitable area, untouched by human habitation and largely hidden beneath thousands of meters of ancient ice. To the casual observer, it appears identical to any other part of the continent, silent, frozen, impassable. However, deep below its surface, concealed under nearly 2 kilometers of glacial crust, something is affecting geophysical instruments, something immense, something unknown. It is referred to as the Wilkes Land Anomaly. First identified in 2006 by NASA satellites measuring gravity, the anomaly manifested not visually, but through mathematical data. A subtle yet persistent gravitational distortion, a vast mass buried below the ice, spanning over 300 kilometers across and descending several kilometers deep. It generates a magnetic pull so powerful that even Earth's gravitational field registers its presence. In the field of geophysics, this type of deviation is unusual. And in Antarctica, where exploration and study are so limited, it is extraordinary. Initially, researchers hypothesized the anomaly might be linked to an ancient impact crater. Satellite imaging data seem to depict a circular structure, an indentation in Earth's crust resembling known impact sites worldwide. Some propose that a massive asteroid, possibly twice the size of the one responsible for the dinosaur extinction, might have struck here approximately 250 million years ago. This time frame is unsettlingly close to the Permian-Triassic extinction event, the most severe mass extinction in Earth's history, which wiped out over 90% of marine and 70% of terrestrial species vanish. Could the impact in Wilkes Land have been the catalyst? It is a compelling hypothesis, supported by structural patterns, gravitational modeling, and the presence of ring-like features beneath the ice. Yet, like all matters in Antarctica, confirmation remains elusive. No drilling has reached the depth required for direct sampling of the area. The ice remains unyielding. The evidence lies buried in silence. Others suggest less dramatic, yet still significant explanations. Perhaps the anomaly is a result of an ancient tectonic structure, an upwelling of mantle material, or a deeply buried mountain range lost beneath the shifting plates of Gondwana. Antarctica, after all, was once part of a vast supercontinent, verdant and forested. Could this be a geological scar remaining from the time before the ice? However, there are more speculative whispers, theories lingering at the fringes of scientific consensus. Some fringe researchers propose the Wilkes Land Anomaly might be something entirely different, an artificial structure, a remnant of a lost civilization, or something originating from beyond Earth. They highlight the seemingly perfect circular shape, the symmetry, and the strange magnetic signatures. They pose questions that mainstream science is hesitant to consider. Could this represent the remains of a colossal, man-made complex long frozen over? A subterranean base? A forgotten metropolis? Or something older than human history itself? In recent decades, Antarctica has become a focus for a new wave of theorists drawn to its inaccessibility and shrouded past. From accounts of Nazi expeditions during World War II and Cold War rumors of concealed technologies, to satellite images revealing unusual patterns in the snow, Antarctica has become a canvas for speculation. The Wilkes Land Anomaly, enigmatic and ideally located, only intensifies this fascination. Naturally, no concrete evidence exists to support these theories. No tunnels, no machinery, no ruins, only readings, numerical data, gravity maps, abstract datasets translated into phantom images on a screen. Nevertheless, it is this absence of certainty that allows the mystery to persist. The lack of definitive answers keeps the door open, even if only slightly. One of the most intriguing aspects of the anomaly is the lack of attention surrounding it. Despite its significance, the Wilkes Land Anomaly rarely captures headlines. Few scientific missions have pursued the initial discovery. Budget limitations, logistical complexities, and the immense difficulty of drilling through Antarctica's frozen crust all contribute to the delays. But for some, the silence itself is suggestive. What if someone already knows what lies beneath? This question remains unspoken among the data points. As the wind continues to sweep over Wilkes Land, the anomaly remains untouched, undisturbed. Whatever lies beneath the ice, whether it be an asteroid, a mountain, or a monument, has waited for millions of years. It will continue to wait. And so we are left with a shape, a signal, a mass, a gravitational whisper from deep beneath the ancient ice. We are aware of its presence. We can measure it, but not yet access it physically. Could this represent the scar of a cosmic cataclysm? A geological relic of Earth's forgotten history, or something else entirely? The answers lie frozen in a place where questions accumulate like snow, layer upon layer, year after year, awaiting the time when someone finally dares to penetrate deeply enough. Just beyond the gravitational enigma of Wilkes Land, descending further into Antarctica's frozen silence, lies another mystery, less massive yet no less profound. If Wilkes Land represents a mystery of stone and ancient impact, then this is a mystery of water, sealed in darkness for millions of years. It originates beneath Russia's Vostok Station, a remote outpost situated atop the East Antarctic ice sheet, among Earth's coldest locales. Here, in an environment so extreme that even bacteria struggle for survival, lies something remarkable: a hidden lake, one situated not on the surface but far beneath it. Entombed under nearly 4 kilometers of ice, untouched by sunlight for as long as 15 million years, Lake Vostok stands as the largest known subglacial lake on the continent and arguably the most mysterious. Discovered in the 1990s through radar imaging, Lake Vostok extends over 250 kilometers in length and holds an amount of water comparable to Lake Ontario. Yet its isolation is absolute. No rivers flow in, no light penetrates. The pressure is immense, the darkness complete, and the temperature barely above freezing. By all accounts, it should be devoid of life. And yet, it may not be. When Russian scientists drilled into the lake in 2012, after years of preparation and international caution, they proceeded with extraordinary care, mindful of potentially contaminating the pristine ecosystem below. What they retrieved was not merely water. The samples contained microscopic life, bacteria, previously unknown species, organisms that had never been observed before, and whose DNA did not match anything cataloged in existing databases. Could these life forms have evolved independently for millions of years, isolated from the rest of Earth's biosphere? Might they contain clues regarding life's adaptability, or even the possibility of life beyond our planet? Some researchers believe this to be the case. Lake Vostok, with its dark, pressurized waters and extreme conditions, has become a model for assessing extraterrestrial habitability. It bears many resemblances to the icy moons of Jupiter and Saturn, Europa and Enceladus, where oceans exist beneath frozen shells, hidden from starlight, warmed by the friction of tidal forces and the internal heat of planetary cores. If life can endure in Lake Vostok, cut off from the sun and surface for epochs, then why not on Europa? However, not all findings are easily explained. Some of the recovered DNA fragments were so unusual, so anomalous, that they appeared to have no place in the known tree of life. One particular set of sequences matched only 86% of known organisms, significantly below the threshold typically accepted for anything familiar. Russian scientists describe them as potentially belonging to a novel type of bacteria or something entirely unknown. Were they contaminants, misinterpreted readings, or did the lake genuinely contain a lineage of life entirely distinct from anything we have ever encountered? The debate remains unresolved. Further complicating the mystery are the physical characteristics of the lake itself. Unlike most bodies of water on Earth, Lake Vostok is capped not just by ice, but by an active thermal dynamic. Heat emanating from Earth's interior maintains its liquid state beneath the ice, and sediment layers at the bottom suggest a history of chemical reactions, volcanic interactions, and geological shifts. Some have even speculated about the presence of hydrothermal vents, fissures on the lakebed that could mimic the deep-sea vents found in our own oceans, where life clusters around plumes of heat and minerals in complete darkness. If such vents exist in Lake Vostok, the possibility of a self-sustaining, complex ecosystem becomes more plausible. Nevertheless, access to the lake remains limited. The initial drilling operations ceased before fully penetrating the water column, and subsequent efforts have progressed slowly, constrained by funding, international environmental agreements, and the sheer technical challenge of boring through miles of ice without compromising the environment. Within this vacuum of certainty, the mystery has deepened. Some fringe theories propose that Lake Vostok might contain more than just biological organisms. Stories have circulated, unconfirmed and largely speculative, about unusual structures detected near the lakebed, about magnetic anomalies, and about unexplained readings within the water. Some have gone so far as to imagine ancient ruins beneath the ice or remnants of lost civilizations preserved by the cold. These ideas are largely dismissed by mainstream science, yet they persist, fueled by the absence of comprehensive information and the allure of the unknown. Why has so little exploration followed the initial discovery? Why is the lake, with all its potential, still largely unstudied? The reality may be less dramatic. It is simply too difficult, too expensive, and too politically sensitive. However, for those drawn to the frontiers of discovery, these unanswered questions resonate more powerfully than any simple explanation. And so Lake Vostok waits, silent beneath its ice ceiling, isolated from the sun, from sound, from time, a sealed capsule of Earth's deep past, or perhaps a preview of other worlds yet to be reached. What forms of life inhabit those waters? What secrets slumber in the sediment? Are we observing the origins of life, or something entirely novel? In the stillness beneath the Antarctic ice, we may be standing on the precipice of the most extraordinary biological discovery of our era, or merely contemplating the ultimate mirror of our own uncertainty. As we journey further into Antarctica's frozen core, past the concealed secrets of Lake Vostok and the unseen mass beneath Wilkes Land, we encounter a sight so striking, so visually incongruous, that it disrupts the white monotony. Amidst the towering glaciers of the McMurdo Dry Valleys, one of Earth's coldest, driest deserts, a stain marks the ice, a cascade of deep red spilling from the frozen cliffs like an open wound upon the glacial face. This is Blood Falls. Emerging from the terminus of the Taylor Glacier, Blood Falls is a rust-colored discharge of liquid that at first glance seems almost supernatural, vivid against the surrounding blue-white expanse. The flow appears to emanate directly from the ice itself. It is a spectacle that has bewildered and captivated explorers since its initial discovery in 1911 by the Australian geologist Thomas Griffith Taylor, who at the time believed that red algae were responsible for the striking coloration. However, as we now understand, the truth is even stranger. The crimson hue of Blood Falls is not biological in origin, but geological. The liquid is a brine, 5 times saltier than seawater, heavily saturated with iron that oxidizes upon contact with the atmosphere. Much like rust, this ancient iron-laden water has been trapped beneath the glacier for over 1 million years, sealed within a pressurized, oxygen-deprived reservoir below the ice. When it seeps to the surface through fissures in the glacier, it interacts with the atmosphere and transforms, turning a vivid blood red as the iron reacts with the air. The scientific explanation is elegant. And yet, it generates more questions than it answers. How does liquid water persist in such an extreme environment, where temperatures frequently drop below 40 Bequenegers? How has this brine remained isolated for such a prolonged period, undisturbed, unfrozen, and alive? Because there is life present in bloodfalls. Samples extracted from the subglacial brine have revealed the existence of microbial life. Tiny organisms thriving in complete darkness under conditions toxic to most known life forms. These microbes subsist not on sunlight, but on sulfate and iron, sustaining themselves in what was previously considered a sterile, lifeless environment. Their survival underscores life's incredible adaptability and the potential for such extreme ecosystems to exist elsewhere. If life can endure beneath the Taylor Glacier in a chemical milieu sealed away for over 1 million years, then perhaps similar forms of life could exist beneath the icy crusts of Europa or Enceladus, or even deep within the Martian permafrost. In this context, Bloodfalls is not merely a curiosity, it is a window into alien habitability, a natural laboratory for astrobiology. Still, certain aspects of the phenomenon remain perplexing. The brine system beneath the glacier is vast and interconnected. Magnetic readings and radar scans have revealed an intricate network of subglacial channels and reservoirs, hidden rivers flowing beneath the ice. These systems are active, dynamic, and still largely unmapped. The depth to which they extend remains unknown, as does their true age. And then there are the more speculative notions, whispers at the periphery of the scientific narrative. Some researchers have noted anomalies in the glacier's behavior, unexplained surges in brine flow, sudden temperature fluctuations within isolated pockets, magnetic disturbances near the source. While many of these readings have logical explanations, subsurface pressure shifts, mineral interactions, or instrumentation errors, others remain ambiguous, uncertain enough to allow for alternative interpretations. Over time, various theories have emerged. Some propose that the brine may conceal entire microbial ecosystems, complex, interdependent, and ancient. Others suggest that the iron-rich outflow might be indicative of a deeper, older process occurring beneath the Antarctic crust, one that predates the glacier itself. More fringe thinkers perceive Bloodfalls as something symbolic, perhaps even a warning. They highlight its unnatural coloration, its persistence, and its location in the dry valleys, one of the few areas in Antarctica not buried by snow. To them, it feels almost like a signal, a red mark upon a white canvas, a message from Earth's profound past. But what message might it be conveying? For scientists, Bloodfalls is a phenomenon of immense research value. For poets and philosophers, it represents a haunting contradiction, a place where life emerges from death, where warmth permeates the cold, and where something seemingly inanimate like a glacier can bleed. It serves as a reminder that Antarctica, despite its apparent stillness, is not static. Beneath its surface, the continent breathes, it shifts, flows, and remembers. And occasionally, it reveals phenomena we are not prepared to comprehend. What lies deeper beneath the Taylor Glacier in the complex network of subglacial water and iron? How many more ecosystems remain, locked away in ice, awaiting release? Could there be life forms there that are older than humanity? Or processes at work that challenge our current understanding of biology, chemistry, and Earth itself? As the red continues to stain the frozen ground, it offers no definitive answers, only questions. And in Antarctica, sometimes a question is the only thing that endures the cold. Moving from the crimson flow of Bloodfalls, where iron-rich water mysteriously bleeds from glacial ice, we encounter a different enigma, one not hidden beneath Antarctica's surface, but meticulously and seemingly precisely inscribed on the surface of aged parchment. In a quiet corner of the Topkapi Palace Museum in Istanbul, preserved behind glass and centuries of speculation, lies a map, torn, faded, and incomplete. At first glance, it resembles any early 16th century maritime chart. But upon closer examination, something becomes apparent that has puzzled historians and scientists for decades. A shape, a landmass, a coastline that should not be present. This is the Piri Reis map, drawn in 1513 by the Ottoman admiral and cartographer Piri Reis. The map is a composite of older source materials, some of which he claimed originated from the era of Alexander the Great. What makes it so remarkable is not merely its age or the detail it displays in a time preceding global navigation, but what it appears to depict: the northern coastline of Antarctica, but not as we know it today. The map illustrates a landmass situated south of the equator, beneath the southern tip of South America. A rugged coastline, seemingly free of ice, with bays, inlets, and mountain ranges that appear to correspond, at least approximately, with modern seismic maps of Queen Maud Land as it would exist without its ice sheet. This is where the mystery begins. Antarctica was not officially discovered until 1820, more than 300 years after the Piri Reis map was created. Even following its discovery, it remained largely unexplored, locked in ice and nearly invisible beneath its frozen covering. And yet this map appears to show the continent not only known, but also ice-free. How could this be? Some scholars propose that the landmass on the Piri Reis map has been misidentified, suggesting it is merely an exaggerated or distorted representation of South America, or perhaps a mythical southern continent common in the speculative geography of that period. After all, early mapmakers frequently filled in unknown areas with artistic embellishments or based their coastlines on hearsay and ancient legends. However, others are not so certain. In 1960, the U.S. Air Force cartographer Charles Hapgood proposed a radical theory. After meticulously studying the map's geographic features, he concluded that it aligned with the subglacial topography of eastern Antarctica with surprising accuracy, more than could be attributed to mere guesswork. Hapgood suggested that this indicated the existence of ancient source maps created before the continent was covered in ice, before Antarctica became icebound approximately 6,000 years ago, or perhaps even much earlier. According to this theory, the original knowledge underpinning the Piri Reis map might have originated from a lost civilization, one possessing the capability to map coastlines with a level of precision not seen again until the era of satellite imaging. Could such a civilization have existed, one with seafaring capabilities, astronomical instruments, and geographic understanding long before the advent of recorded history? Mainstream historians exercise caution. They point to inaccuracies within the map, inconsistencies in scale, and the absence of corroborating evidence for such advanced pre-Ice Age cultures. Many believe that the resemblance to Antarctica is simply coincidental, or that the map's coastline has been misinterpreted. After all, early maps were often compiled from numerous overlapping sources, some accurate, others purely speculative. Yet the anomaly persists. The Piri Reis map continues to exist in the ambiguous realm between cartography and mystery. Adding to the intrigue are the map's origins. Piri Reis himself claimed to have utilized more than 20 older charts, some from ancient seafarers, others from Arab or possibly Greek sources. What were these maps? Where did they come from? And why have they disappeared? The concept of a preserved memory of ancient knowledge, passed down through cultures, distorted over time, yet never entirely lost, has long fascinated those who study forbidden or forgotten history. Could the Piri Reis map represent a remnant of that memory, a cartographic echo from an earlier world? Others take the mystery even further. They question whether Antarctica was perpetually covered in ice. Geological studies have confirmed that Antarctica's climate has undergone dramatic shifts over millennia. During the Pliocene epoch, around 5 million years ago, portions of the continent may have been ice-free. However, no human civilization is known to have existed during that period, unless, of course, something has been overlooked, something buried. Satellite imaging of Antarctica has revealed peculiar geometric formations beneath the ice, structures that some claim are too regular, too angular to be natural. A pyramid-like shape here, a grid-like pattern there. Are these merely geological formations distorted by the interplay of shadow and snow, or something else? The Piri Reis map offers no clarity on this matter. It provides no explanation, no legend, no compass indicating the anomalies it may or may not contain. But its presence lingers in the realm of unexplained history, a fragment, a suggestion, a map that appears to possess knowledge beyond its time. Could an ancient mariner have glimpsed the shores of a warmer Antarctica? Could an unknown culture have transmitted its knowledge across centuries, only for it to be rediscovered in an era unready to grasp it? Or is the entire mystery an illusion, an accidental arrangement of shapes and shadows, interpreted through our desire to find meaning where none exists? The parchment remains unchanged. Its lines still trace an impossible coastline. And in the cold silence of Antarctica, the land it may describe slumbers beneath a mile of ice, waiting perhaps for someone to create the next map. From the mysterious coastlines etched into ancient maps to the continent's frozen stillness, Antarctica has consistently defied simple explanations. It safeguards its secrets effectively, beneath ice, across time, and sometimes beyond our complete understanding. For here at the planet's southernmost point, scientists have detected phenomena truly strange. Not shapes, not structures, but particles, transient messengers from realms far beyond our own. High upon the Antarctic plateau, where snow stretches flat and dazzling beneath a sky untouched by pollution or sound, sits a device called ANITA, the Antarctic Impulsive Transient Antenna. Suspended from a balloon soaring more than 35 kilometers above Earth, this high-altitude experiment was designed not to observe outer space, but to peer downward through the Earth itself. Its objective? To detect high-energy cosmic particles, specifically neutrinos. These ethereal particles are among the most elusive in the universe. Trillions pass through our bodies every second without leaving any trace. They are nearly massless, rarely interact with matter, and originate from the most violent cosmic events: exploding stars, colliding black holes, even the very genesis of the universe. Most neutrinos traverse Earth entirely unimpeded. However, occasionally a high-energy neutrino will collide with an atom, triggering a cascade of secondary particles. It is these interactions that ANITA endeavors to detect by capturing the brief radio bursts emitted as the particles propel upward through the Antarctic ice. But in 2016, ANITA registered something unexpected, twice. Instead of detecting neutrinos originating from space and passing through Earth, the experiment recorded signals that appeared to emanate from within the Earth and travel upward, as if something incredibly energetic, something unlike any known particle, was bursting forth from the ground. This contradicted the predictions of physics laws. Neutrinos of such high energy should not be capable of traversing Earth at all, not without interacting, not without being stopped. Yet these anomalous detections suggested otherwise. Something, either a particle that should not exist or one that violates known rules, was behaving in a manner that demanded explanation. So, what precisely did ANITA detect? The scientific community reacted with caution. Some theorists proposed that the events might be attributable to previously unknown interactions involving tau neutrinos, one of the three types of neutrinos recognized in physics. Others considered more unconventional possibilities: sterile neutrinos, supersymmetric particles, or errors in data interpretation. However, none of the standard models provided an easy fit. The upward-pointing signals challenged the fundamental framework of our understanding of high-energy particles. What made the puzzle even more peculiar was that a separate Antarctic observatory, IceCube, a neutrino detector embedded deep within the South Pole's ice, had not recorded the same events. Although sensitive to similar phenomena, IceCube remained silent. For some, this discrepancy added to the mystery. And as is common with anomalies that resist simple explanation, speculation soon expanded. What if these were not merely rare particles, but something entirely novel? What if the source was not astrophysical, but artificial? Could these events suggest unknown technologies operating beyond our detection capabilities? Could they represent signs of matter or energy traversing dimensions? Or, most controversially, could they be evidence of something extraterrestrial? The term alien particles quickly gained traction in headlines and online discussions. It is a phrase laden with implications, often misunderstood, sometimes misused, but in this context, it reflects a genuine scientific mystery. Perhaps not alien in the cinematic sense, but alien to our current models, alien to the standard model of physics, alien to everything we believed we understood about how the universe functions. To be clear, no scientist claims that these particles definitively prove the existence of intelligent life. However, they do suggest that our understanding of the universe may still be incomplete. that perhaps beneath the ice of Antarctica, we are witnessing not a hidden civilization, but the boundaries of a hidden physics. Why is it consistently in this continent of extremes that our instruments encounter the inexplicable? Is it the pristine quality of the ice, the isolation from external interference, or something more fundamental, something encoded within the land itself? What is particularly compelling is the pattern emerging across various Antarctic mysteries. Not just ancient maps, buried lakes, or magnetic anomalies, but now invisible particles penetrating upward through the Earth, as if attempting to communicate something, trying to reveal a flaw in our assumptions. A hidden doorway in a place where survival is nearly impossible for most life. We may be catching a glimpse of some of the most elusive truths about the cosmos, and yet the data remains limited, the signals are few, the interpretations continue to be debated. Are these anomalies indications of a new class of particles, misinterpreted atmospheric events, or brief flashes from a realm of physics we have yet to map? As the Antarctic winds sweep across a land of ancient ice, the mystery persists. The answers, if they exist, are as silent as the particles themselves, passing unnoticed, unfelt, until one leaves a mark, until one breaks through. Just as the invisible cosmic messengers challenge our understanding of physics beneath the Antarctic skies, the secrets buried deep within the ice recount a different kind of narrative, one not concerning the future, but the profound, forgotten past. Beneath Antarctica's dense white crust, where silence reigns and temperatures rarely rise above freezing, lies a world that seems almost inconceivable. Not a cavern, not a fossilized ruin, but a forest. A rainforest, lush, green, ancient, entombed under more than a mile of ice. In 2019, an international team of scientists drilled into the ice of West Antarctica near the Amundsen Sea, in a region widely considered entirely inhospitable to complex life. What they extracted was astonishing. A core sample containing a dark, compacted layer of sediment that was not merely rock or ice, but soil. Preserved within it were fossilized roots, pollen grains, and even fragments of wood, minute microscopic clues that painted a drastically different portrait of Antarctica's history. Approximately 90 million years ago, during the mid-Cretaceous period, Antarctica, it appears, was not the frozen desert we observe today. It was warm, temperate, covered in dense, swampy rainforest, a land where conifers, ferns, and flowering plants flourished in fertile soil, where rivers flowed beneath a canopy of trees, and where dinosaurs roamed during the unique, shifting twilight of polar seasons. How could such a landscape have existed at the bottom of the world? At that time, the continent was still connected to parts of what would eventually become Australia and South America. It was situated closer to the South Pole than it is currently, yet was significantly warmer, likely due to a combination of elevated atmospheric carbon dioxide levels and a global greenhouse climate. The world was different then. Sea levels were higher, there were no ice caps at either pole, and yet even during months of darkness, the rainforest endured. The discovery is more than a point of interest. It fundamentally alters our understanding of climate, geology, and life itself. It compels us to question how a region now defined by ice could once have supported such vibrant ecosystems, how life not only survived but thrived in a place where modern assumptions dictate it should not have, and what else might still be buried beneath that ice. The fossilized forest beneath Antarctica is not a solitary grove or isolated patch. Evidence of ancient vegetation has been found in multiple regions, in both East and West Antarctica alike. Petrified wood, leaf imprints, even traces of insect activity. In some instances, coal deposits suggest vast areas of dense jungle that flourished for millions of years before being gradually engulfed by advancing glaciers. But what caused this transformation? What turned rainforest into a barren wasteland? Around 34 million years ago, Earth underwent a dramatic shift. The warm greenhouse world began to cool. Antarctica drifted further southward, and as ocean currents changed, the continent was cut off from the warmer waters of the tropics. Ice began to form, slowly at first, then with increasing intensity, until the entire landmass was buried beneath kilometers of snow and ice. The forest froze, the rivers vanished, the soil became locked away in silence. Still, certain questions remain unanswered. How much of this ancient world persists intact beneath the ice? Could entire ecosystems lie preserved in the cold, awaiting revelation? What kinds of organisms might have adapted to that transition, surviving the freeze in microbial form or perfectly fossilized detail? Even more curiously, some researchers have found indications of geothermal heat beneath the Antarctic crust, pockets where volcanic activity warms the ground from below. Could these regions have preserved more than just soil and pollen? Could they harbor clues to evolutionary branches we have never encountered? Life forms that diverge in isolation beneath the expanding ice? In recent years, satellite imaging and radar mapping have revealed a more dynamic Antarctica than previously conceived, crisscrossed by subglacial lakes, mountain ranges, and buried canyons. Could these hidden landscapes contain traces of the ancient rainforest, or perhaps even remnants of something older? Something predating human history altogether? And then there are the more speculative interpretations. Some fringe theorists suggest that the discovery of ancient forests points to a lost chapter in human or pre-human civilization. If Antarctica was once temperate, could it have sustained intelligent life? Could mythologies of lost continents, Atlantis, Mu, Lemuria, have been inspired by faint ancestral memories of this green southern land? There is no concrete evidence for such claims, but the idea persists, fueled by the sheer scale of what remains unknown. What we do know is that Antarctica is not a static wasteland. It is a continent in constant motion, historically, climatically, geologically, a place that once teemed with warmth, life, and growth, a place that remembers. And now, with ice melting at an accelerating rate unprecedented in recorded history, those memories are resurfacing. The soil, when thawed, still carries the fragrance of ancient vegetation. The pollen, viewed under a microscope, glows with colors not seen in the open air for 80 million years. What else might lie waiting, silent beneath the weight of time? Could there be seeds still preserved in the permafrost? Could they one day be revitalized? Or has the past been locked away for too long to ever return? In Antarctica, the boundary between past and present blurs with each core sample, each seismic scan. The ice is not merely a covering, it is a vault. And somewhere within its depths, the echoes of a lost forest still whisper beneath the frost. As we delve deeper into Antarctica's buried past, from ancient rainforests to long-vanished climates, we encounter a mystery not of what once grew here, but of what still stands, silent, immense, and unseen. Beneath the core of East Antarctica, far below the Earth's thickest ice sheet, lies one of the most astonishing and elusive mountain ranges ever discovered. A range as vast as the Alps, with peaks ascending over 3,000 meters high, yet not a single one breaches the surface. These are the Gamburtsev Mountains, named after the Soviet geophysicist Grigory Gamburtsev. This concealed range was first detected in 1958 during a Soviet expedition employing seismic instruments. The data revealed a dramatic and unexpected topography: jagged peaks, deep valleys, and plateaus, frozen in darkness for over 30 million years. For decades, the existence of these mountains remained little more than a ghostly imprint beneath the ice. A rumor within the data, a shadow on a screen. But as technology advanced, our perception of this forgotten world expanded. In the early 2000s, an international team of scientists conducted an extensive geophysical survey utilizing ice-penetrating radar, gravity readings, and seismic measurements. What they uncovered was breathtaking: a complex alpine mountain system, larger than many surface ranges on other continents, encompassing entire watersheds, glacial basins, steep ridges, and broad plateaus, untouched by wind, rain, or erosion for tens of millions of years. And yet, the greatest mystery was not merely how the mountains had remained preserved beneath the ice. It was how they came to exist there at all. According to most models of plate tectonics, mountain ranges form through the collision of two landmasses, forcefully uplifting rock. But the Gamburtsev Mountains are situated at the center of an ancient continental craton, far from any active plate boundaries. Their presence is inexplicable. There is no clear indication of a collision zone, no recent fault lines, no apparent geological reason for these mountains to be present. So, How did they form? One theory suggests that the mountains are extremely old, perhaps exceeding 1 billion years in age, that they were once part of a supercontinent rising during an ancient orogeny before being eroded and subsequently uplifted again. Another proposes that they are remnants of a rift system that formed when tectonic plates began to separate and then, paradoxically, became frozen in place. However, none of these models fully account for the Gamburtsev's significant height or their remarkable preservation. Even more perplexing is the possibility that these buried peaks played a pivotal role in Antarctica's transformation into the icy continent we know today. Scientists now theorize that the Gamburtsev Mountains may have served as the nucleus for Antarctica's vast ice sheet, that their high elevation and complex topography created the initial conditions conducive to snow and ice accumulation, ultimately developing into the massive glacial body that would cover the entire continent. In this perspective, the mountains are not simply a curiosity, they are the silent architects of a planetary scale shift. But how do mountains concealed for millions of years influence global climate in history? Could their valleys contain sediments holding a climate record dating back to before the first ice formation? Could lakes exist within the basins, between their peaks, sealed under pressure like Lake Vostok, potentially harboring ancient life or unknown geochemical processes? Or is it conceivable that beneath the deepest ice, preserved within some undisturbed cavern, there lies an ecosystem or a historical record that we have not yet imagined? Some researchers have speculated about geothermal anomalies beneath the range, unexplained heat signatures that may suggest underlying volcanic or tectonic activity, perhaps even hidden pockets of warmth that have influenced the formation of the ice above. Others observe the range's symmetry, its sharp contours, and its seemingly youthful features, which should not be present in such an ancient, geologically stable region. Could there be more beneath the ice than just rock, more than erosion and uplift? Fringe theorists, as is their tendency, propose more audacious ideas, some envisioning buried ruins, lost technologies, or the remnants of an antediluvian civilization encased within glacial time. While there is no evidence to support such claims, the sheer inaccessibility of the Gamburtsev Mountains renders them fertile ground for speculation. For now, they remain unvisited, beyond reach by traditional methods, mapped solely through echo and inference. And perhaps that is the source of their power. Unlike other mountain ranges that dominate the horizon, the Gamburtsevs are invisible. We perceive them only through their reflection in instruments, through gravitational fluctuations, radar pulses, and the faint trembling signals of seismic waves. They are both real and spectral, solid yet unattainable. What secrets might be locked within their rocks? What relics of Earth's earliest life, earliest water, earliest geological shifts? In a world mapped with millimeter precision by satellites and drones, the notion of an entire mountain range, larger than the Alps, still hidden beneath ice evokes something rare: wonder, awe, and perhaps a quiet reminder of the vast extent of our remaining ignorance. The Gamburtsev Mountains remain inaccessible, buried beneath 4 kilometers of silent, frozen time. But their peaks, lost beneath the planet's weight, still cast a shadow over the frontier of our understanding. And one cannot help but ponder what else lies concealed beneath the ice, waiting to emerge in the data like mountains rising from the deep. Beneath the uninterrupted silence of the East Antarctic ice sheet, where buried mountain ranges lie dormant in absolute darkness, another shadow lingers, less geological, more historical. A human narrative intertwined with secrecy and speculation, linked not to tectonic shifts or ancient forests, but to conflict, ideology, and one of the most clandestine regimes of the 20th century. This is the story of the lost Nazi expeditions to Antarctica. In early 1939, merely months before the eruption of World War II, a specially equipped German vessel set sail from Hamburg under the command of the Third Reich. Its destination, Queen Maud Land, a remote icebound sector of Antarctica claimed at the time by Norway. The ship was the Schwabenland. Aboard were aircraft, scientists, and a carefully selected detachment from the German Navy and Luftwaffe. The expedition was far more than a mere adventure. It was meticulously planned, outfitted with long-range aircraft modified for icy terrain. Over several weeks, the German contingent deployed thousands of metallic darts, each bearing a swastika insignia, across a vast expanse of land, effectively asserting territorial claim. They designated the region Neuschwabenland. Official records state that the expedition was primarily scientific, focused on mapping, meteorological research, and securing potential whaling grounds to support the German war economy. And in many respects, that explanation holds true. The mission returned with aerial photographs, ice core data, and climate observations. Nothing overtly unusual, nothing seemingly sinister, and yet the expedition was never repeated. Why dispatch a military-backed operation to a distant frozen wilderness on the cusp of global war? Why claim territory that would offer no strategic advantage in a conventional military sense? And, more curiously, why do rumors persist to this day suggesting that something more transpired there? Something that was never officially documented? In the decades following the collapse of Nazi Germany, whispers intensified. Claims circulated of secret Antarctic bases, bunkers constructed deep within the rock, hidden beneath the ice. Allegations emerged of German U-boats escaping southward in the final days of the war, transporting high-ranking officials and classified technologies to safety beyond the reach of Allied forces. Some pointed to the U-977 and U-530, two German submarines that surrendered months after the war's conclusion, their late arrival and whereabouts during that period mysteriously unaccounted for. Could they have been part of a final escape, a retreat to a last refuge? By the late 1940s, the United States initiated a large-scale military operation to Antarctica, Operation High Jump, commanded by Admiral Richard E. Byrd. Officially, the mission was described as a training and research exercise intended to establish an American presence in the region. However, the scale of the deployment was remarkable. 13 ships, 33 aircraft, and over 4,700 personnel. Some observers questioned the necessity of such a formidable force. What did the United States anticipate finding or confronting? Admiral Byrd himself made cryptic remarks in a post-mission interview, cautioning that the United States must prepare to defend against aircraft capable of flying from pole to pole at extraordinary speeds. His comments, ambiguous and alarming, have been interpreted in various ways. Some dismiss them as misinterpretations, others as deliberate misdirection. But the fundamental questions endure. What was the actual purpose of Nazi Germany's Antarctic expedition? Was it genuinely limited to scientific research, or was something more covert underway? And if a base was indeed established, what might have been its objective? Research, sanctuary, or something more arcane? Some theories, far outside the mainstream, speculate about a continuation of Nazi interest in the occult. Legends of hidden technologies, anti-gravity craft, and unusual energy sources surface repeatedly in fringe literature. These notions are typically disregarded by historians, yet their persistence is noteworthy. Fueled by a lack of transparency, incomplete archives, and the Cold War's culture of secrecy, they have become intertwined with a form of modern mythology. There are claims, unverified and unverifiable, of vast caverns beneath the ice, warmed by geothermal heat and capable of housing entire facilities, of salvaged technologies spirited away in the aftermath of the war, and even of sightings, strange lights, aircraft, and objects moving beneath the surface radar. More measured investigations have examined the geology of Queen Maud Land and identified plausible locations where caves and ice-free pockets could potentially exist. Beneath the glacier, heat from Earth's interior creates isolated zones of liquid water and potentially habitable space. Could these areas have been utilized or at least explored by early expeditions? If so, why the continued silence? To this day, the fate of certain wartime records remains unknown. Portions of the Nazi archives were destroyed. Others were confiscated by Allied intelligence agencies and classified. Among these might lie the complete account of Neuschwabenland. Or perhaps it was never more than it seemed, a brief, peculiar diversion by a regime craving scientific prestige. But the mystery persists because so little has been definitively confirmed and so much remains physically inaccessible. Queen Maud Land remains remote, hostile, and largely impenetrable. No known structure has ever been discovered. No conclusive proof has emerged of underground facilities or surviving technology. And yet periodically within the white silence of Antarctica, new anomalies surface. Magnetic readings, thermal signatures, unexplained formations buried beneath the ice. Coincidence or clues? Was Antarctica merely a setting for wartime ambitions or a deeper chapter in a story that continues to unfold? The questions linger, echoing in the frost just beyond the boundary of certainty. As we leave behind the icy legends of clandestine bunkers and vanished expeditions, we return once more to what resides deep beneath the Antarctic surface. Not relics of war or ancient cartography, but something far older and potentially more volatile. Beneath the immense silence of the ice sheet, in isolated pockets located miles below the surface, something stirs in the darkness. Not movement, not sound, but pressure, chemical potential. A slow, imperceptible force sealed within the frozen crust for millions of years. These are Antarctica's subglacial methane reservoirs, hidden repositories of gas trapped beneath the ice, preserved within ancient sediments that have not been exposed to sunlight since long before the emergence of humanity. The discovery of these reservoirs has occurred only in recent decades as ground-penetrating radar, seismic readings, and satellite-based observations have revealed startling anomalies beneath the continent's frozen shell. In the low-lying sediment basins beneath West Antarctica, particularly beneath the Whillans and Mercer ice streams, scientists have identified extensive deposits of organic-rich material, former seafloors and floodplains buried by shifting ice and time. Within this organic matter, under immense pressure and aided by geothermal warmth, methane has formed. Methane, an invisible, odorless gas, simple in its molecular structure, yet profoundly potent in its effects. Trapped beneath hundreds of meters of ice, it waits. But for how long? Under the right conditions, methane can remain confined for millennia. It can combine with water to form clathrates, crystalline ice structures that imprison gas within a frozen lattice. These structures maintain stability only under specific pressures and temperatures. However, Antarctica is not entirely static. Beneath the ice sheet, geothermal heat rises from Earth's core. Subglacial lakes shift and drain. Ice streams flow slowly but relentlessly toward the coast. And as global temperatures ascend, the surface above begins to melt, not just at the edges, but from within. Could these changes disrupt the ancient equilibrium? What happens if the ice thins, the pressure decreases, or the temperature rises just enough to destabilize the balance? Could massive plumes of methane be suddenly released, as has been observed in Siberia and the Arctic Ocean? The implications are sobering. Methane is a greenhouse gas over 25 times more effective than carbon dioxide at trapping heat in the atmosphere. A sudden, large-scale release from Antarctic reservoirs, measured in gigatons, could dramatically intensify climate change. It would constitute not merely an environmental shift, but a positive feedback loop capable of accelerating ice melt, sea level rise, and planetary warming in unpredictable ways. But the mystery extends beyond climate science. There is another layer to this buried system, one less understood and far more captivating. Within the sediment cores extracted from beneath the West Antarctic ice sheet, researchers have found more than just gas. They have discovered ancient microbial life, organisms that survive in oxygen-deprived, high-pressure, methane-rich environments. These microbes subsist by feeding off the carbon trapped within the ice and sediment, generating methane in the process. Could some of the methane reservoirs we detect today be biologically active, not merely static pockets of gas, but dynamic, self-sustaining ecosystems sealed away beneath the ice for millions of years? The idea is no longer merely theoretical. In isolated subglacial lakes like Lake Whillans and Lake Mercer, scientists have identified living microbial communities thriving in total darkness. They metabolize carbon and sulfur compounds, adapt to extreme salinity, and exist under hundreds of meters of ice without access to sunlight or atmospheric oxygen. These life forms may represent some of the most resilient organisms on Earth, serving as models for survival on other planets or moons. Could similar life exist within the methane-bearing sediments beneath Antarctica's ice? And if so, what form does this life take? Ancient strains from Earth's deep past, or something that evolved in complete isolation, cut off from every other branch of the biosphere? The deeper the drills penetrate, the stranger the world revealed. Some have begun to speculate about the broader significance of these discoveries. If methane is being actively produced by life forms deep beneath the Antarctic ice, could that account for some of the unexpected gas signatures detected in other parts of the continent? Could there be methane seeps, slow and steady, contributing to unexplained atmospheric patterns? Could it even be linked to the more anomalous radar readings, temperature fluctuations, or magnetic anomalies detected in nearby regions? And extending the questions further, are we merely uncovering the remnants of Earth's ancient cycles, or are we disturbing a delicate balance that we barely comprehend? Fringe theories have also entered the conversation. Some suggest that under certain conditions, these methane reservoirs combined with geothermal vents, liquid water, and trapped oxygen could form the basis for complex ecosystems. The concept of hidden biospheres, of warmth and energy existing beneath the frozen wasteland, has become a source of fascination not only for scientists, but also for writers, thinkers, and those who explore the edges of conventional knowledge. Is it possible that life beneath Antarctica never ceased, but simply adapted, burrowed deeper, and waited? Could an entire layer of the planet's evolutionary history be unfolding beneath the ice, concealed from us not by distance, but by depth? For now, the methane remains confined, sealed beneath layers of ice and time, but the equilibrium is fragile. And in a world experiencing changing temperatures and shifting climates, the pressure is mounting. What else lurks in the dark? What else awaits release? Chemical, biological, or something even stranger? In Antarctica, even the silence possesses a form of respiration. From the pressurized silence of methane-filled sediments to the microbial respiration of life sealed beneath ancient ice, Antarctica continues to unveil secrets far predating our written history. However, one question, more expansive, more haunting, refuses to dissipate, even in the face of scientific skepticism. A question that has echoed for decades through whispered theories and cryptic clues. Could an ancient civilization have once existed beneath the Antarctic ice? It is an idea that stretches the limits of imagination, and yet the landscape itself seems to invite the question. Envision it, a continent larger than Europe, enveloped in a sheath of ice exceeding 2 kilometers in thickness. Beneath that frozen layer lies a continent not of barren rock, but of mountains, valleys, river basins, and lost shorelines. Features that were once exposed to the open sky, rain, and forests. Geological studies corroborate this. Antarctica was not perpetually frozen. Tens of millions of years ago, it supported vast forests, wetlands, and temperate climates. Even as recently as 6,000 years ago, according to some controversial climate models, parts of its coast may have been free of ice. And yet there are no ruins, no temples, no tools, no evidence of agriculture, no inscriptions carved in stone. Still, questions persist. Some of the earliest hints of this mystery can be traced to the 16th century Piri Reis map, whose enigmatic southern coastline has long been interpreted by some as a depiction of an ice-free Antarctica. While mainstream scholars view the map as a compilation of earlier charts incorporating distortions common to the cartography of the time, others perceive in it the outline of a landmass that should not have been known. Could it reflect a distant memory passed down through ancient seafarers long before the modern era? More recently, satellite imagery has added to the intrigue. High-resolution scans have revealed anomalies beneath the ice, linear formations, geometric patterns, and symmetrical shapes that appear to the observer unusually regular. Among the most frequently discussed is a structure near the Shackleton Range, an arrangement of ridges and depressions that, viewed from above, bears a resemblance to the layout of a city grid. Another is a dome-like formation protruding from the ice, with concentric circles that echo Plato's description of Atlantis. Skeptics argue that these features are natural glacial formations, nunataks, and rock exposures, shaped by millennia of pressure and ice flow. And in many cases, this may indeed be true. But the question remains, can we definitively dismiss the possibility of something more? Some fringe theorists have taken this further, drawing upon myths of lost civilizations, Atlantis, Lemuria, Mu, and aligning their hypothesized locations with the shifting poles of Earth's axis. According to the controversial Earth crust displacement theory proposed in the mid-20th century, the entire crust of the Earth may have shifted abruptly in the ancient past, relocating Antarctica from a more temperate zone to its current polar position. If this theory were valid, and if human or pre-human civilizations existed during that period, then much of their history could now lie buried under ice, inaccessible and forgotten. There is, of course, no concrete archaeological evidence to substantiate these claims. However, in 2017, seismic and ground-penetrating radar studies detected a series of subglacial features in East Antarctica that further fueled speculation. Among them, anomalous heat signatures, localized magnetic fluctuations, and unusual topographic formations buried deep beneath the surface. Could these represent ancient structures, remnants of walls or foundations? Or are they simply a consequence of geothermal activity, tectonic stress, or geological upheaval that occurred long ago? Scientists remain cautious. The Antarctic Treaty prohibits large-scale excavation, and the sheer difficulty of drilling through miles of ice makes direct investigation nearly impossible. The answers, if they exist, remain out of reach for now. Nevertheless, the human mind is drawn to patterns, to possibilities, to mysteries that seem just beyond clear focus. We possess so little knowledge about the earliest chapters of our species, the rise and fall of cultures now lost to sand, forests, and oceans. Entire cities have vanished under volcanic ash, jungle foliage, and rising seas. Why not beneath ice? Is it possible that beneath the Antarctic plateau lies not merely frozen rock, but forgotten memory? Some believe that if we were ever able to drill deeper, scan more clearly, or interpret the landscape more fully, we might find not the fantastical ruins of science fiction, but subtle traces, a carved stone, a buried hearth, a tool, something small, inconspicuous, yet undeniable, a fragment of a history we were never taught. Until that possibility arises, Antarctica remains the most inaccessible of archives. A continent of ice, yes, but also of profound silence, one that guards its history with the immense weight of time itself. And so, we are left with this persistent thought. If a civilization did indeed flourish here before the ice arrived, before memory solidified into myth, how would we ever ascertain its existence? And more curiously, if something lies beneath, dare we truly uncover it? In a world where so much has been mapped, measured, and explained, Antarctica continues to offer the only response it has ever provided. Wait, watch, wonder. From speculations of ancient civilizations lost beneath the ice, we return once more to the quiet, living heart of Antarctica, far below its surface, where sunlight cannot penetrate and time seems to stand still. But here, within this dark, pressurized realm, something is in motion, something microscopic, ancient, and very much alive. Scattered beneath Antarctica's vast ice sheet are over 400 known subglacial lakes, bodies of liquid water sealed under kilometers of ice, isolated from the atmosphere for millions of years. These lakes exist in a delicate balance, subjected to crushing pressure, warmed by geothermal heat, and insulated by the overlying ice. In their silence, they present something extraordinary, a window into the deep past, into Earth's forgotten biology. Among them, Lake Willans and Lake Mercer, located beneath the West Antarctic ice sheet, have become subjects of intense scientific exploration. In recent years, teams from the Willans Ice Stream Subglacial Access Research Drilling Project, known as WISARD, successfully drilled into these lakes, obtaining water samples never before exposed to the outside world. What they discovered within challenged all prior assumptions. Despite the extreme conditions, absence of light, sub-zero temperatures, crushing pressure, and complete isolation, life exists. The samples revealed thriving microbial ecosystems composed of bacteria that survive by breaking down minerals in the surrounding sediments and consuming iron, sulfur, and methane. These microorganisms are not dependent on photosynthesis, as surface life is. Instead, they rely on chemosynthesis, extracting energy from the very rocks and chemical reactions around them. It is a survival strategy more commonly associated with life found at the deepest ocean vents than beneath polar ice. But here, in these hidden lakes, life has not only endured, it has adapted. Some of the recovered DNA sequences exhibit little resemblance to anything currently known. They suggest lineages that diverged long ago, perhaps before the last ice age, or even before the formation of Antarctica as we recognize it. Could these microbes be survivors from a time when the continent was still warm and forested? Organisms that retreated into the depths as the ice advanced, persisting through epochs of cold and clandestine, sunless waters? And if so, what insights might they still hold within them? What knowledge? What chemistry? What history? The implications extend far beyond Antarctica. These life forms have become valuable models for what might exist on other worlds. On the icy moons of Jupiter and Saturn, where oceans lie hidden beneath crusts of ice, just as they do here, Europa and Enceladus. If life can flourish in the sealed lakes of Antarctica, might it not do the same in the subsurface seas of other planets? NASA and other space agencies have taken note. The drilling techniques pioneered in Antarctica now inform the planning of future space missions, where robotic probes might one day bore through extraterrestrial ice in pursuit of alien microbes. In this sense, Antarctica serves as a testing ground, not only for terrestrial science, but for the search for life beyond Earth. However, back on this planet, the mysteries continue to deepen. Not all subglacial lakes are identical. Some, such as Vostok, one of the largest and deepest, remain largely unexplored. Sealed for at least 15 million years, Vostok's waters may potentially host entirely unique biospheres shaped by pressures and chemistries unknown elsewhere on Earth. In preliminary analyses of samples collected near the lake, scientists found traces of DNA that could not be easily classified. While contamination is always a concern, the possibility of undiscovered life remains tantalizing, leading to more profound questions. If life can survive, isolated from the surface for millions of years, what else might be preserved within these waters? Could microorganisms retain ancient genetic memories, snapshots of Earth's biosphere prior to the rise of mammals? Could they represent alternative evolutionary paths shaped by isolation and adaptation? Or even microbial fossils, long deceased, that record biochemistry from vanished eras? In the most speculative realms of thought, some ponder whether these lakes might contain more than just microbes. If the complex ecosystems hinted at by certain sediment samples, rich in organic compounds, could include more elaborate organisms, nematodes, extremophilic fungi, even multicellular life that evolved in absolute darkness. No conclusive evidence yet confirms this, but no expedition has ever penetrated deeply or for long enough to definitively rule it out. And so we are left with a simple, astonishing truth, that in the coldest, most remote location on Earth, life may be thriving in silence, unaffected by the sun, unaware of the surface world, evolving in a realm so alien that it feels more akin to science fiction than planetary science. How many more of these lakes lie waiting, undetected beneath the ice? How many forms of life have yet to be cataloged, isolated, or awakened? Could unlocking their secrets provide insights not just into biology, but into time, resilience, and the very limits of existence? Or might we uncover something far more unforeseen? In Antarctica, even the smallest organism can carry the weight of immense mystery. Even the simplest cell can hold an ancient truth. And as long as the ice endures, so too will the questions, untouched, unresolved, and quietly alive beneath our feet. From the microcosmic resilience of ancient life forms thriving in subglacial lakes, we turn now to a different kind of mystery. One not biological, but geological, a force that pulses beneath the ice, silent and invisible, yet capable of reshaping the very foundations of the frozen continent above. Welcome to Merry Birdland. Remote, windswept, and hauntingly vast, Merry Birdland stands as one of the most isolated regions in all of Antarctica. Situated in West Antarctica between the Ross Sea and the Amundsen Sea, it spans over 1.5 million square kilometers and remains one of the few major land masses on Earth without any permanent human presence. Even among the desolate expanses of Antarctica, Marie Byrd Land feels uniquely untouched. Its barren plains are observed primarily by satellites and passing storms. However, beneath this solitary stretch of ice, something peculiar is occurring. In recent decades, scientists conducting radar and seismic surveys across West Antarctica began detecting an anomaly deep beneath the surface. Hidden below Marie Byrd Land lies a region of unexpected warmth, an anomalous heat source that appears to emanate directly from Earth's crust beneath the ice sheet. This is not a subtle phenomenon. This subterranean heat is actively melting the base of the ice sheet, creating vast subglacial lakes and lubricating the ice above, causing it to flow more rapidly towards the ocean. The presence of geothermal heat beneath Antarctica is not in itself surprising. The continent is, after all, home to known volcanoes, some of which remain active, and a number of geothermal hotspots. But the heat source beneath Marie Byrd Land is exceptional in its intensity and scale. Satellite measurements of ice elevation and gravitational fields suggest that a large plume of heat, possibly a mantle plume, is concentrated in this region, extending upward from deep within Earth's interior. And yet, the data does not entirely align. The plume appears relatively young in geological terms, perhaps tens of millions of years old, yet it underlies ice that has been stable for a significantly longer period. Some scientists propose that this mantle heat may be a crucial factor explaining why the West Antarctic ice sheet is considerably less stable than its eastern counterpart. But others pose a different question. Why specifically here, and why now? What accounts for Marie Byrd Land being the focal point of such a powerful, concentrated heat source? Is it a natural consequence of mantle convection, a lingering scar from past tectonic collisions? Or is it something else entirely, something we have yet to fully comprehend? Adding to the intrigue is the unusual positioning of Marie Byrd Land within what is known as the West Antarctic Rift System, a vast, partially submerged tectonic boundary that has stretched and thinned the crust of this region over millions of years. Some researchers believe that the anomalous heat is rising through these fractured zones, where Earth's interior is unusually close to the surface. Others speculate more boldly. The shape and behavior of the heat plume bear certain resemblances to volcanic hotspots found in areas like Yellowstone and Iceland, regions where magma wells up from deep within the planet, sometimes with dramatic, even catastrophic consequences. Could Marie Byrd Land be concealing a similar feature, a massive, slow-burning supervolcano buried under kilometers of ice? There is no evident eruption crater, no definitive sign of a volcanic caldera, but satellite observations have detected areas of ice surface uplift, subtle bulges suggesting that something beneath is expanding, heating, and pushing upward. And then there are the stranger questions. Why does the magnetic field in this area fluctuate more than expected? What explains the subtle yet persistent gravitational anomalies that have been detected from orbit? Could there be massive voids, caverns, or even hollowed-out chambers beneath the surface, formed by geothermal activity or by something else entirely? To some, these questions echo more fringe theories, ideas about artificial heat sources, hidden bases, or even ancient machinery buried beneath the ice. Such notions are not supported by mainstream science, yet they persist in the public imagination, fueled by the remoteness of the location, the strangeness of the data, and the long history of secrets associated with Antarctica. What is known, however, is this. The anomalous heat source beneath Marie Byrd Land is altering the landscape above it. It is accelerating ice flow, creating meltwater lakes, and destabilizing the West Antarctic ice sheet in subtle but significant ways. And it may be contributing to the acceleration of a much larger process, one with global implications. As the ice thins and flows more rapidly toward the sea, sea levels rise. Coastal cities worldwide are impacted. Entire ecosystems undergo shifts. And the mystery that originates with warmth in the frozen south extends outward, connecting continents and future possibilities. But the underlying cause, the true nature of the heat source, remains unresolved. Is this the initial manifestation of a long-dormant geological force gradually awakening? Or is it simply another element within Earth's complex and ever-changing system, misunderstood only because we have not yet grasped the complete picture? Ultimately, Marie Land maintains its silence. There are no expedition bases here, no lights, no roads, only ice and something concealed beneath it. And as the warm breath of the earth ascends from the darkness, melting the underside of Antarctica's ancient ice crown, one cannot help but wonder what else stirs in the depths, unseen, unknown, and still awaiting identification. As we depart from the strange warmth rising from beneath Marie Land, we re-emerge into the cold, but not into the blinding white expanse that characterizes so much of Antarctica. Instead, we arrive at a place where the ice entirely disappears, a place that seems impossible within a land of snow and glaciers. This is the McMurdo Dry Valleys. Situated between colossal mountain ranges near the Ross Sea coast, the dry valleys extend across a vast area of rocky desert, an Antarctic anomaly. Here the ice recedes, leaving windswept plains exposed, scorched not by sunlight, but by the constant abrasion of katabatic winds. Bone-dry gales that descend from the polar plateau at speeds exceeding 300 kilometers per hour, evaporating any trace of moisture in their path. The result is an environment that feels otherworldly. Jagged hills of exposed rock ascend above gravel plains, where not a drop of rain has fallen for nearly 2 million years. The air is so arid that lakes fed by distant glacial melt form thick, icy crusts, beneath which hypersaline water persists, silently defying the climate. The landscape feels devoid of life, lunar and ancient, and yet something remarkable survives here. Despite the absence of liquid water, plant life, or any visible signs of a sustaining ecosystem, life endures within the dry valleys. In the soil beneath the surface, and even within the ice of frozen lakes, extremophile organisms, tiny, resilient microbes, have adapted to this brutal environment in ways that science is still striving to comprehend. Some survive by adhering to minerals, extracting sustenance from chemical reactions within the rock itself. Others inhabit the ice layers, photosynthesizing through thin veins of meltwater during summer's brief light. These life forms operate at the very limit of possibility, stretching our definitions of what constitutes a habitable environment. If such life can thrive here, in Earth's most extreme environment, what might that imply about other barren worlds? NASA and other space agencies frequently utilize the dry valleys as an analog for Mars. The similarities are striking: dry, cold, wind-blasted, and seemingly inert, yet still capable of harboring life. It serves as one of the best terrestrial test beds for planetary exploration. Rovers and sampling technologies intended for Mars are tested here among the rocks and permafrost. But there is something else about the dry valleys, something more difficult to articulate. They feel untouched, possessing a silence that is deeper than mere quiet, an unsettling stillness. The land carries the profound calm of deep time, like a place that has paused between moments for a duration far exceeding what seems natural. Explorers and researchers who have traversed these valleys often describe a sense of being observed, not by any discernible presence, but by the intrinsic weight of the place itself, as though the stones retain a memory we do not. And then there are the anomalies. Certain geological formations within the dry valleys remain challenging to explain. Polygonal patterned ground, strange geometric tessellations etched into the soil, have formed without the typical frost cycles, seemingly contradicting local climatic conditions. Boulders have been discovered perched in perfect equilibrium, with no apparent explanation for how they reach such improbable positions. And in certain parts of the valleys, magnetic readings have fluctuated unexpectedly, suggesting localized irregularities within Earth's crust. One of the region's most well-known mysteries is Blood Falls, an iron-rich, rust-colored stream that seeps from the Taylor Glacier and flows onto the valley floor. The source of the red liquid lies deep beneath the ice, within a pressurized subglacial reservoir where microbial life metabolizes iron in oxygen-deprived darkness. How this isolated ecosystem has persisted for so long and why it manifests so strikingly in this desolate environment remains a subject of ongoing research and speculation. Some have pondered whether there is more than just unusual chemistry at play here. Could these valleys, with their peculiar alignments, hidden life, and unsettling stillness, contain remnants of something older? Something not merely natural, but perhaps indicative of intelligence? No evidence suggests that human or pre-human civilizations ever settled Antarctica. And yet, the geometry of the landscape prompts the question, the symmetry, the stark isolation, the suggestion of deliberate purpose behind the shapes sculpted by wind and time. Even within mainstream scientific discourse, the dry valleys are viewed as time capsules, windows into what Earth once was or what it might one day become, a preview of a dying planet, or the vestiges of a world preceding our own. And so, the dry valleys remain one of Antarctica's most studied yet least understood features. Every rock, every salt-encrusted lake bed, every whisper of wind traversing its canyons seems to convey a message written in a language we are only just beginning to decipher. What was this land like before the onset of the cold? What else might lie dormant beneath the cracked surface, awaiting a thaw that may never occur? And perhaps more unsettlingly, are we truly alone in the silence? Or are we simply too recent, too transient, to grasp the ancient memory held within the stones? In the end, the dry valleys do not demand answers, but rather questions. And in Antarctica, that is where all discovery originates. From the spectral silence of the dry valleys, where life struggles yet something lingers, we now descend into the hidden arteries of the continent, into places not merely below the ice, but intrinsic to it, into passages of frozen light, into vast luminous chambers that few have witnessed and fewer still have truly comprehended. Welcome to Antarctica's blue ice caverns. Concealed beneath glaciers and ice shelves, extending beneath the Ross Ice Shelf and deep within the coastal boundaries of the continent, these caverns are not discernible from the air. They are typically discovered by chance, through satellite thermal imaging, radar anomalies, or during hazardous field expeditions, probing fissures in the glacial surface. When researchers do locate them and venture inside, the spectacle they encounter is unlike anything else on Earth. The air becomes still, the temperature drops, the walls shimmer. Everything is immersed in an eerie, unearthly glow, the product of pure, compressed ice, absorbing red light and scattering only the deepest, most spectral blue. The deeper one penetrates, the more the ice transforms into a crystalline substance, transparent, prismatic, imbued with vibrant color. Some of these caverns span hundreds of meters. Arched ceilings ascend like the domes of cathedrals, sculpted not by human hands, but by geothermal vents, subglacial rivers, and gradual unseen melt cycles. In certain locations, shafts of light penetrate through overhead cracks, painting the walls with a hue so profound and saturated it feels surreal, like traversing frozen moonlight. However, the beauty masks a deeper mystery. Why do some of these ice caverns form in seemingly random locations, far from known heat sources? Why do they retain their structural integrity while the surrounding ice flows and shifts over time? And how can some of them be so vast, so structurally stable, within a landscape otherwise defined by movement and collapse? One of the most striking examples lies beneath Mount Erebus, Antarctica's most active volcano. Here, ice caves are formed by geothermal heat rising through the mountain's flanks. The walls are thick with hoarfrost and crystalline formations that gleam like glass, and the interior remains surprisingly warm, around freezing, even during the coldest months. Sensors placed within these caverns have detected unusual gas mixtures, including elevated levels of methane and carbon dioxide, as well as minor fluctuations in magnetic activity. While some of this can be attributed to volcanic activity, not all of it can. Other caves, such as those found beneath the Ross Ice Shelf or near the edge of the Transantarctic Mountains, are not associated with volcanic systems. In these regions, caverns appear without obvious geothermal origins, and some are connected to unexplored subglacial lakes, creating complex networks of frozen passages. The walls are sometimes remarkably smooth. In rare instances, explorers have reported symmetrical formations, repeating patterns that appear carved rather than melted. Are these simply the result of consistent glacial erosion, subsurface meltwater sculpting the ice over time? Or could they indicate a more complex, perhaps episodic process, one involving deeper flows of geothermal energy or even long-vanished atmospheric conditions that left behind structural remnants within the ice? No one knows for certain. Some scientists speculate that ancient methane bursts or intermittent geothermal surges from deep within the crust may have contributed to shaping these caverns. Others suggest that some of the caves may function as pressure valves, natural release points for subglacial tension where gases accumulate and are periodically discharged. These processes, if more fully understood, could help explain phenomena ranging from ice sheet movement to atmospheric anomalies above the poles. And then, of course, there are the more speculative theories. Over the years, rumors have emerged of immense caverns large enough to accommodate aircraft, equipment, or even exploratory outposts. Spaces so deep and sheltered that they maintain a constant temperature and remain undetectable by satellite. Some fringe theorists have suggested these caverns as potential locations for lost expeditions, hidden technologies, or even remnants of civilizations buried before the ice came. While such claims lack supporting evidence, they are not entirely unfounded in pure imagination. The sheer scale and obscurity of these caverns invite speculation. In places where light never penetrates and ice shifts on timescales beyond human comprehension, even the rational mind begins to wonder, what else might lie hidden? Could these caves preserve ancient life, sealed in ice since before the last interglacial period? Could they store atmospheric records or mineral traces untouched by erosion or exposure? Or perhaps, most compellingly, could they be interconnected, linking lakes, vents, and deeper geological features into a subterranean network beneath the continent? We know that Antarctica harbors hundreds of subglacial lakes connected by rivers flowing in darkness. We know that methane accumulates beneath the ice, that ancient microbes endure where conventional life should not, and that seismic readings hint at unexplored hollow spaces. Might these glowing caverns represent more than just isolated features? Might they be the entryway to something larger? As researchers continue to map the ice sheet using radar and satellite technology, new anomalies emerge. Pockets of unexpected warmth, voids beneath the surface, even subtle shifts in magnetic signatures. But field access is restricted, drilling is costly, and the risks of collapsing caverns or sudden gas release are too significant for most expeditions. So for now, these cathedrals of blue light remain largely undisturbed, their walls murmuring with the echoes of melting centuries, their depths safeguarding silence like a secret. And in a continent shaped by extremes, by absence, by stillness, by time stretched thin and cold, these luminous hollows may be some of the last places where the unknown still glows, patiently waiting in the dark. What forces molded them? What histories lie frozen within? And if we dared to venture deeper, what might we find glowing in the ice beneath the silence, millions of years deep? From the blue, luminous caverns deep within the ice, we now emerge into the dazzling brightness of the Antarctic surface, into a vast alien white landscape where movement seems absent and time itself feels suspended. But here, scattered across the ice like messages from the cosmos, lies one of the continent's most unexpected treasures: meteorites. In the field of planetary science, no other place on Earth is quite as ideal as Antarctica for locating rocks that have originated from space. Each year, as the Antarctic winds scour the surface and the ice slowly migrates across the continent, dark stones appear, small, silent, and distinctly out of place. In a land composed almost entirely of white and blue, a black rock stands out like a beacon. Some of these meteorites are no larger than a human fist. Others weigh several kilograms, but all of them share a remarkable history. They arrived here from beyond our world. What makes Antarctica so uniquely suitable for collecting meteorites is not merely the color contrast. It is the way the ice preserves them. Unlike other regions of the planet where wind, water, and soil rapidly erode or bury space rocks, the Antarctic cold maintains their integrity. The dryness prevents rust. The ice gradually transports them towards mountain ranges, known as stranding zones, and the surface winds eventually expose them, enabling researchers to simply walk across the ice, searching for the foreign objects amidst the familiar environment. Since systematic searches commenced in the 1970s, more than 60,000 meteorites have been recovered from the continent. Many are fragments of asteroids that fractured long ago in the asteroid belt. Some have been traced back to the moon. A rare few originate from Mars, but it is not solely their extraterrestrial origin that captivates scientists. It is what they potentially contain. Meteorites are true time capsules. Time. Locked within them are minerals, isotopes, and even gases that predate Earth itself. They carry the chemical fingerprints of the early solar system, preserved in a frozen state for billions of years. Some contain the fundamental building blocks of life, organic compounds such as amino acids, carbon chains, and even water-bearing minerals formed in the cold of interstellar space and delivered to our planet through cosmic collisions. Could these fragments have once seeded Earth with the essential ingredients for life? This question has preoccupied astrobiologists for decades, and in Antarctica, it finds fertile ground. In 1984, a small black rock was discovered in the Allen Hills region of Antarctica. Catalogued as ALH 2001, it would eventually become one of the most controversial meteorites ever studied. Following detailed analysis, NASA scientists in the 1990s announced that the meteorite, originating from Mars, contained possible microfossils, tiny worm-like structures embedded within the rock, along with mineral patterns and organic molecules, suggesting biological processes. Was this evidence of ancient Martian life? The scientific community engaged in intense debate. Many argued that the structures could have formed through purely geological processes, and that the organic compounds might be due to contamination or abiotic in origin. But the notion that a rock discovered in Antarctica might contain remnants of life from another world had already taken root. The matter remains unresolved, and ALH 84001 is not an isolated case. Other Antarctic meteorites have revealed unusual isotopic ratios, peculiar crystalline structures, and patterns of chemical weathering indicative of long, slow journeys through space and unknown interactions before their arrival here. Some researchers have highlighted the presence of nanodiamonds within certain meteorites, formed under pressures not found on Earth or during standard meteorite collisions. Others have noted inclusions of hydrogen isotopes that may trace back to interstellar clouds, suggesting that at least some of the material within these rocks predates our entire solar system. What are we truly holding when we lift one of these ancient fragments from the ice? A splinter from a shattered planet? A survivor of a cosmic explosion? A messenger from a place far beyond the reach of any spacecraft? And yet, mysteries closer to Earth also exist. In 2022, a team of researchers uncovered one of the largest meteorites ever found in Antarctica, a 17-pound specimen buried just beneath the surface. Its composition, age, and trajectory are still undergoing analysis, but its discovery prompts familiar, haunting questions. How many more lie concealed beneath the ice? How many ancient fragments of Mars, the Moon, or something even stranger are waiting, preserved in silence, awaiting the day they are uncovered? The extreme cold and remoteness of the continent have made systematic exploration challenging. Many regions remain unsearched, and the possibility persists that larger, older, or more complex meteorites have yet to be found. Some may lie beneath glaciers, slowly migrating over millennia. Others may rest near known heat anomalies, where the ice is thinned and ancient materials might be exposed. And then there is the more profound, more speculative idea. If meteorites are capable of delivering life-bearing molecules to Earth, could they have delivered something more? Could some fragments, rare, ancient, and as yet unrecognized, carry not merely chemical blueprints, but something more structured, a form of code, a signature, a signal? There is no definitive proof of such a possibility, and yet the allure remains. In Antarctica, beneath the indifferent sky, meteorites lie in waiting, cold, ancient, and silent. Each one a mystery, each one a story older than Earth itself. And as long as we continue our search, the ice may still surprise us, offering pieces of the cosmos, hidden in plain sight, beneath a land of snow and silence. From the dark stones of space scattered across the Antarctic ice, we turn now to something originating not among the stars, but from the seas. Something ancient, immense, and almost unbelievable. Not a meteorite, but a fossil. Not from another world, but from an earlier Earth. Buried in rock, not ice. Concealed beneath layers of time, rather than snow. In Antarctica, paleontologists have unearthed the remains of giants, of prehistoric creatures that once dominated the southern oceans. And among the most extraordinary, most captivating of these are the fossils of giant penguins. Here in a land now largely inhospitable to nearly all life, scientists have discovered the remains of birds that defy conventional expectations. Penguins that once stood nearly 2 meters tall, over 6 feet, and weighed more than 100 kilograms. Towering, flightless predators that moved through ancient oceans with power and elegance. Creatures that, by size alone, would dwarf their modern counterparts. The most notable among them is Paleodiptus klekowski, a species discovered on Seymour Island near the Antarctic Peninsula. Its fossils date back approximately 37 million years to the late Eocene epoch, a period when Antarctica was not the frozen desert it is today, but a lush, forested landscape supporting rich ecosystems both on land and in the surrounding seas. These prehistoric penguins inhabited a very different Antarctica. The climate was mild, temperatures were warmer, and the continent remained connected by land bridges to South America and Australia. It was a place teeming with life, of ancient whales, massive sharks, and imposing seabirds that hunted in waters abundant with fish. But why did penguins attain such enormous size? Some scientists believe their size conferred an evolutionary advantage. With no terrestrial predators posing a threat, and with plentiful prey in the water, penguins may have grown larger to enhance their diving capabilities, conserve body heat more effectively, and dominate ecological niches. Their bone structure reveals adaptations for deep, powerful swimming, suggesting they could dive for longer durations and hunt more effectively than their smaller descendants. Yet as the climate cooled and Antarctica began its prolonged transition into an icy state, these giants vanished. Fossil records indicate a decline in their size and diversity, replaced by smaller, more specialized species, many of which survive today. Nevertheless, the fossils they left behind tell a story that feels almost mythological. Imagine standing in the shadow of such a creature, a penguin taller than a grown man, fearless and silent, built like a hybrid of a seal and a bird. What sounds did they make? How did they behave on land? What role did they play in the food web of a long-vanished ocean? Some remains suggest that multiple species of large penguins may have coexisted, forming a diverse and complex avian community. Other fossils hint at potential evolutionary links to seabirds that no longer exist, suggesting that Antarctica may have once been a crucible for avian evolution, a forgotten frontier of flightless giants and feathered aquatic hunters. But there are deeper mysteries. Fossils of giant penguins have been found not only in Antarctica, but also in New Zealand, Peru, and even parts of Africa, regions that were once connected through the supercontinent Gondwana. This distribution raises questions about ancient migration routes and evolutionary divergence. Did these penguins spread from a common ancestor across connected continents? Or did similar species evolve independently in isolated ecosystems? More curiously, some fossilized bones appear more robust, less avian, and denser, prompting fringe theorists to speculate about lost species still unknown to science. Some claim that beneath the ice, perfectly preserved remains of even larger, undiscovered birds might still exist. Others point to unusual imprints in the permafrost, interpreted by some as giant webbed footprints, although no conclusive evidence supports these claims. In certain regions where sedimentary rocks are exposed through the ice, near Seymour Island or on the Antarctic Peninsula, geological layers rich in fossils remain only partially explored. What other species lie entombed within these stone time capsules? What other forms of life walked, swam, or dove through these waters before the glaciers arrived? And within the silence of this ice-covered world, could some fossil beds remain perfectly preserved, undisturbed for tens of millions of years? The conditions are ideal: cold, isolated, undisturbed. Antarctica, in its frozen state, may serve as one of Earth's best natural archives of prehistoric life, but much of it remains unexplored, buried beneath kilometers of snow and stone. And so we are left with fragments: a femur here, a partial beak there, enough to envision, but never quite enough to grasp the complete picture. Enough to know they existed, enough to wonder what else they left behind. The giant penguins of Antarctica represent more than just a biological curiosity. They are a reminder that this continent, now so empty, so barren, was once vibrant with color, motion, and towering feathered hunters. that the ice is not merely silence, but memory, that what seems lifeless may still be narrating a story, one layer at a time. How many more fossils await discovery beneath the ice? How much of Earth's lost history remains frozen beneath our feet, quiet, ancient, and unseen? And if creatures this extraordinary once flourished here, what else might have? As we leave behind the fossilized remains of ancient penguin giants, once rulers of Antarctic shores, we shift our focus from the remnants of the visible world to the invisible forces that quietly shape it. Forces that are constant, relentless, and at times unexpectedly peculiar. Beneath the thick ice and windswept silence of Antarctica, something intriguing has been detected. Not a sound, not a light, but a subtle shift, a whisper within the planet's gravitational field. In 2002, scientists analyzing satellite data from NASA's GRACE mission, Gravity Recovery and Climate Experiment, discovered an anomaly beneath the icy expanse of East Antarctica. In a region known as Wilkes Land, satellite instruments registered an unexpected gravitational fluctuation, a vast, circular area where the gravitational pull was measurably weaker than in the surrounding regions. To the human body, gravity feels stable, unchanging. But to the highly sensitive instruments orbiting above our planet, it is dynamic, altering with the mass, density, and structure beneath the surface. And in this instance, the GRACE data revealed something remarkable. A gravitational anomaly exceeding 300 kilometers in width, stretching beneath one of the continent's most desolate and least explored regions. What could account for such a phenomenon? The most straightforward explanation relates to mass, or rather the deficiency thereof. A decrease in gravitational pull typically indicates a region where mass is missing, displaced, or possesses unusually low density. In Antarctica, where kilometers of ice conceal the geological structures below, such fluctuations provide rare insights into the unseen subsurface. Some researchers hypothesize that this anomaly marks the site of an ancient impact, possibly from a massive asteroid that struck Earth approximately 250 million years ago. The depression within the gravitational field could represent a buried crater, now hidden beneath miles of accumulated ice and sediment. If this hypothesis is correct, it would rank among the largest known impact sites on Earth, potentially rivaling or even surpassing the Chicxulub crater associated with the extinction of the dinosaurs. And yet, no definitive crater rim has been confirmed. No shocked quartz, no solidified melt rock, no clear iridium layer. The ice, despite its vast memory, retains its secrets effectively. Other explanations suggest geological processes, perhaps a region of the crust thinned by ancient rifting or an unusual mantle plume beneath the surface. Antarctica's tectonic history is complex and only partially understood. Could this gravitational anomaly be a natural consequence of long-forgotten shifts in Earth's crust? A concealed rift valley? A collapsed mountain range? And then, as is inevitable, there are the more speculative interpretations. Some fringe theorists have proposed that the anomaly's nearly circular shape and deep central depression resemble the geometry of artificial structures buried beneath ice for millennia. They point to the anomaly's location within the same region as the Wilkes Land magnetic anomaly as further evidence of something more, a convergence of gravitational, magnetic, and seismic irregularities. Could this suggest something constructed by humans or something pre-human in origin? No evidence supports these ideas, but the mystery persists. Adding to the intrigue is the fact that multiple gravitational fluctuations have now been detected across Antarctica, not solely in Wilkes Land, but also in smaller, more localized pockets. These areas of weaker gravity suggest variations in subsurface structure, some aligning with known geological formations, others lacking a clear explanation. Why do certain regions exhibit such pronounced gravitational contrasts when the ice above shows no visible disruption? Could these fluctuations be connected to buried lakes, ancient seabeds, or even reservoirs of dense rock or metal? Could they be signaling undiscovered features, massive voids or filled chambers hidden for millions of years beneath the unyielding ice? The GRACE and GRACE-FO missions continue to collect data, measuring not only long-term ice loss, but also these deeper, subtler features of Earth's gravitational landscape. However, interpretation remains challenging. Every measurement is influenced by layers of ice, crust, and mantle, each with its own density and dynamic behavior. In many respects, we remain unaware of the deeper Earth, and nowhere is that lack of awareness more profound than in Antarctica, a continent where more is concealed than revealed, where gravity itself appears to curve around the unknown. In a world increasingly mapped, scanned, and digitized, it is rare to encounter a region that resists comprehensive explanation. But Antarctica provides just that. A landscape of anomalies where even the most fundamental forces, like gravity, can behave in unexpected ways. What lies beneath these fluctuations? Are they the echoes of ancient impacts, geological scars from a time preceding human memory? Are they indicators of deep Earth processes, still active and shifting beneath the ice? Or could they represent the signatures of something entirely different, something we have not yet conceived? As we continue to measure the world with increasing precision, such questions only become more prominent. Earth still retains its secrets, and in the silence beneath Antarctica's frozen shell, gravity itself may be the first to reveal what remains unseen. From the deep, unseen tremors of gravitational anomalies beneath Wilkes Land, we now shift our perspective skyward, not towards the stars, but back towards Earth, to the view from high above, where Antarctica reveals patterns too vast to be perceived from the ground. Strange, elegant formations etched into the ice, geometric, precise, almost unnatural. In recent years, satellite imagery over parts of East Antarctica has captured something unexpected. Vast stretches of ice marked by perfectly symmetrical, hexagonal patterns. Resembling the scales of some colossal, ancient white creature, or the crystalline veins of a frozen web, these shapes extend across the surface in ways that defy easy explanation. At first glance, they bear a similarity to the polygonal patterns observed in frozen ground across Arctic tundra features caused by seasonal freezing and thawing cycles. But in Antarctica, where some regions have remained frozen for millions of years, such regularity raises questions. The hexagons, some spanning tens of meters across, appear in specific areas, often near ancient ice domes or subglacial basins. From an aerial perspective, their outlines form a grid of frozen geometry, appearing almost architectural. Too perfect, some suggest, to be random, too precise to be overlooked. So what is the cause of these patterns? The most widely accepted theory points to a natural process known as thermal contraction cracking. As temperatures plummet, the surface ice contracts, forming stress fractures. Over time, these fractures intersect and develop into polygons, with hexagons representing the most stable shape for evenly distributing tension, much like the way cracks form in drying mud, or how basalt columns develop hexagonal joints as cooling lava solidifies. However, in Antarctica, the scale and sharpness of these hexagons seem unusual. The cold here is extreme and continuous, without the dramatic seasonal variations found in the Arctic. In some regions where these patterns have been observed, the ice is believed to be over 1 million years old, stable, unmoving, and sealed in silence. Why then are these geometric patterns emerging now? Some researchers propose that shifting climate patterns or geothermal heat from below might be subtly altering the surface, triggering cracking in ways we do not yet fully comprehend. Others suggest that the influence of subglacial water rising and falling beneath the ice might be contributing to surface tension that manifests in unexpected forms. But not everyone agrees with these explanations. A small number of observers have proposed alternative possibilities, more speculative yet equally intriguing. Could these patterns be indicators of deeper structures, whether natural or artificial, pushing upward from below? In some areas, the hexagonal patterns align suspiciously well with localized magnetic anomalies or gravitational disturbances. Are we simply observing the surface manifestation of something deeper, something hidden beneath miles of ice? Even more controversially, some point to the hexagon as a shape holding significance in both natural systems and engineered design. It is a form that appears in beehives, in carbon molecules, in snowflakes, and in human architecture. Could these formations be more than a geological coincidence? Could they represent remnants of something constructed, now buried and reshaped by time and ice? There is no evidence to support such claims, and yet the questions persist because what satellite imagery reveals is not chaotic. It is ordered, repeating, structured. In one sector, not far from Dome Fuji, scientists observed hexagonal impressions extending nearly a kilometer, with each cell of the pattern almost identical in size and shape. Ground-level expeditions confirmed the pattern, but found no immediate indications of its depth or whether it was currently forming or fossilized. Attempts to scan beneath the ice using radar have yielded mixed results. In some cases, the echoes suggest voids or density anomalies beneath the pattern's surface. In others, the ice appears uniform. However, the data remains incomplete. Access to these regions is challenging, and each year snow accumulation further obscures the patterns, preserving them in some seasons and concealing them in others. Could these formations be transient, a fragile skin on a dynamic body of ice? Or could they be stable, persisting for decades, even centuries, without anyone noticing until now? And if they are natural, why do they occur here? Why are there so many? And why in such remote and specific regions? Antarctica has always been a continent of hidden shapes, mountain ranges taller than the Alps, buried lakes sealed from light for millions of years, magnetic fields that twist and shift unpredictably. But these surface patterns, visible from orbit yet invisible on the ground, present a new kind of enigma, a geometry that seems simultaneously ancient and recent, familiar and alien. As new satellites continue to pass overhead, capturing high-resolution imagery of the continent's frozen surface, more such formations are coming into focus. Some are faint, others strikingly clear. And while many may be explained through known scientific principles, a few continue to elude certainty. Do these hexagons speak solely of ice and pressure? Or are they part of a deeper language inscribed across the continent in lines and forms that we have only just begun to interpret? What lies beneath this geometry? What stories are encoded within these frozen shapes that only satellites can perceive? And if these patterns represent merely the beginning, what else might Antarctica be revealing? One perfect hexagon at a time. As we trace the frozen lines of hexagonal geometry across Antarctica's icy surface, another pattern emerges, less regular, more enigmatic. Not a shape of symmetry, but of violent disruption. Vast depressions, circular and immense, concealed deep beneath the ice, places where the land itself appears to have been impacted, hollowed out, or collapsed. These are Antarctica's peculiar crater-like structures, formations that stimulate debate among scientists and ignite the imagination of those who study them. Beneath kilometers of ice in East Antarctica, radar scans have revealed massive circular anomalies, some spanning over 300 kilometers in diameter. They are not discernible to the naked eye, nor are they marked by familiar features such as mountain ridges or ice domes. Instead, they manifest only in seismic echoes, gravitational maps, and subglacial topography models detected by satellites and ice-penetrating radar. Deep bowls carved into the crust, their rims faint, their centers appearing darker in gravitational readings. One of the most studied lies beneath Wilkes Land, where a dense mass anomaly aligns suspiciously well with what many believe is a buried impact structure. If it is indeed a crater, its size would rival or exceed that of the Chicxulub impact in Mexico, the event responsible for the dinosaur extinction. And yet, unlike Chicxulub, this structure exhibits no irrefutable signs of an impact. No shocked quartz, no solidified melt rock, no iridium layer. The ice, despite its vast memory, retains its secrets effectively. So what caused these formations? Some geologists support the impact hypothesis. They propose that a massive asteroid, perhaps over 50 kilometers wide, struck Earth during the Permian-Triassic era, approximately 250 million years ago, triggering the most devastating extinction event in the planet's history. The correlation of timing, location, and structure is compelling. Others argue that these formations may be collapsed calderas, ancient supervolcanoes that erupted and subsequently subsided long before being entombed by ice. Antarctica's geological past is still poorly understood, but seismic data suggests widespread volcanic activity beneath the ice sheet. Could these crater-like structures be remnants of titanic eruptions, their outlines preserved in rock but hidden from the world above. There is also a third possibility. Some researchers believe these anomalies could be the result of isostatic rebound, a process where land previously depressed by ancient ice sheets slowly rises and reshapes after the ice retreats. Could these depressions be relics of long-lost glacial basins, distorted by millions of years of tectonic and thermal motion? And then, on the outer edge of speculation, the questions become even stranger. If these circular formations do not conform to impact or volcanic signatures, what else could have caused them? Some theorists have proposed that such shapes could represent the remnants of ancient structures, whether artificial or engineered, buried by time and ice, vast domes or subterranean facilities that have since been crushed or collapsed. Proponents of this view point to the near-perfect roundness of certain depressions, the concentric ridges, and the occasional hints of radial symmetry. They note the anomalies in gravity and magnetism that sometimes coincide with these sites. But without direct access, without excavation or sample retrieval, such theories remain speculative, compelling, but unconfirmed. And Antarctica does not yield its answers readily. The immense thickness of the ice poses an almost insurmountable challenge. In some locations, the overlying ice sheet exceeds 4 kilometers in thickness. Drilling projects, even the most ambitious, rarely penetrate deeply enough to reach the base of such formations. Radar and satellite data provide only shadows and shapes, glimpses of something larger, hidden just beyond reach. Furthermore, the inherent stability of the ice may preserve not only geological features, but also secrets. Unlike other regions on Earth where erosion, tectonic activity, and vegetation obscure the past, Antarctica holds it in place. If these craters are indeed impacts or collapses, they may be among the best preserved examples on the planet. If they are something else, something older or more complex, they may still be waiting, unchanged beneath the ice. Why do so many of these structures remain unnamed, unexplored? Why do some maps indicate anomalies only for them to vanish in subsequent data releases? Are we examining the data too closely or not closely enough? As scientific equipment improves and more extensive surveys are conducted, we may begin to perceive more clearly what lies beneath these enigmatic depressions. Until then, the craters remain a quiet mystery, uncharted bowls within a frozen land, their silence more profound than certainty. Are we observing scars left by cataclysm or windows into a chapter of Earth's history that has never been recounted? Whatever the answer, these crater-like structures represent not merely questions of shape and scale, they are questions of origin, of history, of the forces that have shaped not only this frozen continent, but perhaps even the destiny of the world itself. And until we penetrate the ice and stand at the edge of one of these vast, unseen hollows, the question will remain suspended in the cold. What occurred here? And what else? From the mysterious depressions concealed beneath the East Antarctic ice, we now shift our focus to the continent's periphery, to a place where the ancient meets the fragile, and where one of the most dramatic events in modern polar history has unfolded visibly. This is not a mystery buried beneath kilometers of frozen silence. It is one we have witnessed collapsing in real time. Welcome to the Larsen Ice Shelf. Extending along the eastern coastline of the Antarctic Peninsula, the Larsen Ice Shelf once formed a massive frozen barrier between the continent and the Weddell Sea. It was segmented into sectors, Larsen A, B, C, and D. Each represented a platform of ancient glacial ice slowly flowing from the land and spreading out over the water like a solidified fan. However, beginning in the 1990s, something unusual began to happen. First, Larsen A disintegrated, breaking into immense shards and drifting into the Southern Ocean. Then in 2002, Larsen B followed suit. In just over a month, an area of ice exceeding 3,000 square kilometers, larger than Luxembourg, shattered into the sea. It was a sudden, almost surgical collapse. The shelf did not gradually melt, it disintegrated. Icebergs the size of cities calved off in rapid succession. What had taken millennia to form vanished in mere days. And then in 2017, Larsen C experienced one of the largest iceberg detachments ever recorded. Iceberg A68, nearly 6,000 square kilometers in size. It broke free and drifted into the Southern Ocean, altering coastlines, navigation routes, and scientific expectations. But what precipitated such a dramatic unraveling? The leading theory attributes it to climate change. The Antarctic Peninsula is among the fastest warming regions on Earth. Rising air temperatures, warmer ocean currents, and surface meltwater collectively weaken the structural integrity of ice shelves from both above and below. Meltwater ponds accumulating on the surface seep into cracks and crevasses, deepening them and forcing the shelf apart, an effect known as hydrofracturing. Meanwhile, warmer seawater erodes the base, melting it from below. But in the case of Larsen B, scientists were astonished by the speed of the collapse. Ice that had held fast for more than 10,000 years fractured in a matter of weeks. What forces could induce such rapid disintegration? Was this an anomaly or a harbinger of future events? Some researchers speculate that the shelf had been in a precarious balance for centuries and that minor changes finally pushed it beyond a critical threshold. Others point to deeper mechanisms, such as shifting gravitational tides, the influence of atmospheric rivers delivering concentrated heat and moisture from tropical regions, or even geomagnetic disturbances affecting sea ice dynamics. Could multiple factors acting in concert have created a perfect storm? And then, more speculative voices ask, did we truly understand what lay beneath Larsen B before it collapsed? Radar surveys of the region conducted prior to the breakup were limited. After the shelf disappeared, researchers discovered previously unknown geological features, including submerged ridges, underwater canyons, and evidence of volcanic heat. Some wondered if geothermal pulses or crustal movements could have played a role. Subsurface forces weakening the ice shelf from below, out of sight. Other theories, currently unproven but persistent, suggest that the sudden collapse may have revealed or concealed more than just glacial dynamics. Could the retreat of the ice have exposed ancient landforms or even fossilized ecosystems that have yet to be studied? Could the release of pressure resulting from the collapse have activated deep-sea systems we are only beginning to detect, such as methane seeps or microbial colonies preserved by the cold? Following the breakup, researchers swiftly moved in to sample sediments from the newly exposed seabed. What they found was unexpected. Rare species of life thriving in the absence of light in ecosystems that had been hidden for over 100,000 years. Unique microbial communities, soft corals, sponges, organisms surviving in total darkness under layers of ice that had never before retreated in the age of human observation. What else might lie beneath other ice shelves, waiting in that frozen dark today? Larsen D remains intact for the time being, but climate models suggest its stability may not endure indefinitely, and each collapse raises a troubling question, not solely for Antarctica, but for the entire world. Ice shelves function as buttresses for the glaciers situated behind them. When they collapse, the glaciers accelerate, discharging more ice into the ocean and directly contributing to sea level rise. The fate of the Larsen ice shelf is not merely a matter of remote geography. It has implications for coastlines in New York, Mumbai, Lagos, and Shanghai. It concerns the potential speed of sea level rise and whether ancient systems we presume to be stable are, in fact, far more vulnerable. Still, one cannot ignore the profound sense of awe. Standing where Larsen B once stood firm, one is struck not only by the magnitude of the loss, but by the silence it left behind. The still water where creaking ice once groaned, the void that was previously a shelf. It is a mystery in reverse, not a secret awaiting uncovering, but one that vanished before we could fully grasp its significance. And so the question persists, did we witness a natural progression or a signal, a warning of deeper changes occurring beneath the ice, unseen and unmeasured? And as other ice shelves begin to crack and creak, what will they reveal when they too fall into the sea? As we move from the crumbling edge of the Larsen ice shelf, where ancient ice dissolves into warming seas, we journey inward, deeper into Antarctica's stark and unforgiving interior. Here, in a place where even bacteria struggle to survive, another mystery emerges. Not beneath the ice this time, but lying silently upon it. Mummified seals, found far from the coast, some over 50 kilometers inland. They lie in contorted, wind-sculpted postures on rocky terrain, not snow. Their skin, hardened and leathery by the freeze, their eyes long gone. their bones weathered by decades or even centuries of exposure. And yet there is no water here, no fish, no potential prey, only barren rock and the Earth's coldest desert. Why are they here? These seal mummies have been discovered primarily within the McMurdo Dry Valleys, Antarctica's most alien-like landscape, an ice-free region where relentless katabatic winds strip moisture from both the air and the ground, preserving anything left exposed. The seals, some still retaining traces of fur, rest on high ridges and gravel plains. Many show signs of starvation, others of disorientation, but none are located where they should be. Modern seals never venture this far from the sea. They are coastal animals, physiologically and instinctually adapted for life along the ice edge. Their anatomy, their behaviors, their entire existence, everything is tied to the ocean. So what compels them to journey deep into the interior, where life is absent and nothing grows? One explanation proposed is navigational error. Some scientists believe that young or ailing seals may become disoriented during storms, mistaking the gleaming white surface of frozen lakes or salt flats for the distant ocean. They follow scent or visual cues inland, traversing increasingly barren terrain until overcome by exhaustion or starvation. Once there, the freezing, exceptionally dry air preserves their remains through a process akin to natural mummification, transforming flesh into parchment and bone into relic. Others suggest that magnetic disturbances may play a role. The dry valleys are situated near known areas of magnetic variation, where Earth's geomagnetic field becomes irregular. Could these fluctuations disorient seals that rely on magnetoreception for navigation? Could they be drawn not by a simple mistake, but by instincts gone awry? However, if it were merely navigational misadventure, why are there so many? Over 100 mummified seals have been found in the dry valleys alone, and more continue to be discovered, sometimes clustered together, sometimes spaced kilometers apart. Some are less than a century old. Others, based on radiocarbon dating, are thousands of years old. Yet their condition remains eerily consistent. Some died alone. Others lie in what appear to be purposeful positions, heads raised, bodies curled, as if they were seeking something. And even stranger, the remains are not limited to seals. In rare instances, researchers have found what appear to be the bones of penguins far from the shore, or the skulls of unidentified animals partially buried in the gravel. Could there have been ancient migration routes, long since obliterated by glacial advance? Were these regions once closer to the coast during a warmer period in Antarctica's distant past? Geological studies do indicate that the Antarctic coastline has shifted significantly over the last few million years. During periods of glacial retreat, marine animals may have ventured inland along now vanished inlets or river systems. But this does not fully account for the persistence of such mummified remains in more recent geological layers. And then, as with so many Antarctic enigmas, more speculative questions begin to surface. Some researchers have pondered whether these seal migrations are not simply a result of error or random drift, but of instinctual behavior, a deep biological memory. Could there be something about the dry valleys, something ancient and long encoded within their biological programming, that draws these creatures here? Others point to seismic or acoustic anomalies detected within the region. The dry valleys resonate with low-frequency vibrations, subtle, natural in origin, and often below the range of human hearing. Could marine animals known for their sensitivity to sound perceive these signals as something meaningful? Could they be following an echo emanating from the Earth itself? Still more fringe theorists entertain ideas of energetic hotspots, ley lines, or natural geophysical features that function like beacons, misinterpreted by animals as channels, pathways, or safe ground. These theories are, of course, unverified, but they stem from the same core mystery, the sheer improbability of what has been found and its location. Why, in one of Earth's most remote and seemingly lifeless places, do we find these frozen visitors? What did they perceive, see, hear, or feel that compelled them so far from their natural habitat? The mummified seals lie still now, untouched by predators or scavengers. their bodies preserved by time and climate, their journey etched into the silence of rock and ice. And yet they remain one of Antarctica's most quietly unsettling puzzles. Are they warnings from the past, natural anomalies, echoes of a shifting Earth? Or are they indicators of something we do not yet grasp? Some unseen connection linking land, sea, instinct, and ice? The dry valleys maintain their silence. The wind howls across the stones, and the seal mummies wait as they have for centuries, their faces directed towards a sky that offers no answers, only questions. From the wind-scoured bones of mummified seals lying silent in the dry valleys, we turn now to another form of life, far smaller, far stranger, and considerably more resilient. Not a creature that is lost, but one that is very much alive, one that does not flee the cold, the darkness, or even radiation. In the shadows of Antarctica, embedded within the ancient ice and stone, scientists have discovered fungi unlike any found elsewhere on Earth. Black, tenacious, and remarkably adaptive, these organisms do not merely survive harsh conditions, they appear to thrive in them. And even more remarkably, some of them seem to sustain themselves by feeding on radiation. This exploration began with studies conducted deep beneath the surface, inside the frozen rocks of the Transantarctic Mountains, and within the subsurface glacial crusts near Concordia Station. Researchers identified colonies of melanized fungi, organisms darkened by high concentrations of melanin, the same pigment found in human skin. However, here, melanin serves a different function. In 2007, parallel research on similar fungi, initially discovered within the irradiated ruins of Chernobyl, suggested that these organisms were not merely tolerating radiation, they were actively absorbing it, utilizing melanin not only for protection, but as a biological tool, a converter, extracting energy from radiation in a manner analogous to how plants utilize sunlight for photosynthesis. Could it be that these Antarctic fungi possess the same capability? Experiments conducted aboard the International Space Station later confirmed this potential. Samples of Cladosporium sphaerospermum, a melanized fungus similar to those found in Antarctica, were sent into orbit. In this environment, they exhibited accelerated growth and enhanced health when exposed to elevated radiation levels, suggesting that ionizing radiation might not only be tolerated, but could be metabolically beneficial. A biological paradox, an organism that transforms what is typically deadly into nourishment. On Earth, such fungi are rare. They inhabit environments where other life cannot survive, cracks within nuclear reactors, caverns miles underground, beneath glaciers, within Antarctic permafrost. They exist where light is absent and where conventional food chains cannot be sustained. But what if this phenomenon is not merely adaptation, but a form of memory? Some scientists have speculated that these fungi may be exceptionally ancient, far predating most forms of terrestrial life. They may trace their lineage back to eras when Earth's surface was more volatile, more radioactive, more extreme. Could their capacity to utilize radiation as a food source be a vestige of a primordial world? A survival mechanism born in an age that we can scarcely imagine? And in Antarctica, where ancient environmental conditions are preserved like fossils in ice, could these organisms be living relics of that time? So far, studies have primarily focused on isolated samples, colonies retrieved from exposed rock faces and frozen soil. However, the possibility remains that much larger, interconnected fungal networks exist beneath the ice, slow-growing, melanized biospheres that tap into geothermal heat, cosmic rays, or even subtle background radiation as their primary energy source. If this were the case, they would represent a form of life profoundly different from our conventional understanding. Not plants, not animals, not microbes in the traditional sense, but something else entirely, an organism that exists not despite extreme conditions, but because of them. One that thrives by consuming what we consider hazardous. And then, as is common with many Antarctic discoveries, questions begin to expand outward. Could such fungi exist on other worlds, in the ice of Europa, in the dark rocks of Mars, or beneath the radiation-bathed surface of Enceladus? Could their remarkable resilience provide a blueprint for survival beyond Earth? NASA and other space agencies have taken notice. If life is capable of metabolizing radiation, It may not require sunlight or traditional chemical nutrients for survival. It might exist wherever energy is present, regardless of its form. And that fundamentally redefines our understanding of what constitutes a habitable environment. Closer to home, the concept of radiation-consuming fungi has even sparked speculation in more unconventional circles. Could such organisms explain certain biological anomalies observed in extreme environments? Might they influence the chemistry of deep Antarctic lakes where radiation slowly permeates through rock and ice? Might they even contribute to unexplained warmth or energy readings detected in subglacial regions? While current evidence does not extend beyond the microbial level, the implications are vast. Because in these fungi, we are confronted with a fundamentally different manifestation of life. Not one that grows towards light or feeds in the customary manner, but one that flourishes within the unseen. One that consumes what we label as dangerous. One that converts energy into survival in ways we do not yet fully comprehend. Are they simply the outcome of billions of years of quiet adaptation? Or are they a glimpse into something more profound? A more ancient logic of biology concealed beneath the world's surface? Antarctica, with its vaults of ice and stone, continues to yield surprises. Each discovery, whether a fossil, a void, or a fungus, uncovers another layer of the unknown. And as we examine more closely, we begin to realize that life may not merely be enduring here, but evolving along entirely distinct pathways. What else awaits discovery in the cold? What forms of life subsist on forces we have only just begun to measure? And in the frozen corners of this silent continent, how many more answers lie shrouded in darkness, patiently drawing strength from that which the rest of life has always feared? From the black fungi that thrive on invisible rays of radiation, we now descend into the depths, into the frigid waters that encircle Antarctica, like a moat of darkness and ice. Beneath the surface, in waters hovering just above freezing, drifts a creature so peculiar, so evolutionarily distinct, that it challenges the very biological principles we take for granted. This is the ice fish, pale, ghost-like, and astonishingly bloodless. Unlike any other known vertebrate, ice fish of the family Channichthidae exist without hemoglobin, the iron-rich protein that imparts red color to blood and transports oxygen to cells. Their blood is clear, their bodies are almost translucent, and yet they survive and flourish in one of Earth's most challenging environments. How? Discovered in the Southern Ocean during the early 20th century, ice fish have long perplexed biologists. In most animals, hemoglobin is essential. Without it, oxygen cannot efficiently reach tissues, and organs would begin to fail. But in ice fish, the genes responsible for hemoglobin have been lost or deactivated, broken fragments remaining like fossils within their DNA. These fish are not merely deficient in hemoglobin, they are entirely devoid of it. So what mechanism sustains their life? The answer lies partly within the icy waters themselves. Cold water retains more dissolved oxygen than warm water, and in the Southern Ocean, where temperatures frequently drop below zero due to high salinity and pressure, oxygen is abundantly available. Ice fish have developed unusually large hearts and wide blood vessels, enabling them to circulate blood at high volume with reduced resistance. Their blood is less viscous, flowing more easily throughout the body. Their metabolism is slow, their muscles are oxygen efficient, and their organs finely adapted to extract every available bit of oxygen from their surroundings. Essentially, they have adapted not by conquering the cold, but by collaborating with it. But why lose hemoglobin altogether? Some researchers propose it was an evolutionary trade-off. As Antarctic waters cooled dramatically millions of years ago, certain fish populations began to evolve in isolation. In an environment with limited competition and oxygen-rich seas, the energy cost of producing hemoglobin may have become unnecessary. Over time, genetic mutations rendered the genes inactive, and the fish adapted to survive without it. Nevertheless, this does not provide a complete explanation. The absence of hemoglobin remains a biological anomaly, one that violates the established rules of vertebrate physiology. In no other vertebrate lineage has such a loss been observed. Why did this particular adaptation occur here and nowhere else? What environmental pressures or genetic occurrences made it possible? And what other hidden mechanisms might support life under such extreme conditions? Icefish also produce specialized antifreeze proteins, molecules that bind to ice crystals and prevent their growth within the body. Without these proteins, their blood would solidify. These proteins are so remarkably efficient that they have inspired research in bioengineering and cryopreservation worldwide. Their origin remains mysterious. Did they evolve independently, or were they repurposed from older, more primitive proteins within the genome? Even stranger, some icefish species exhibit signs of vestigial red blood cells, tiny, inactive remnants of a function that was lost. Could these represent evolutionary holdovers from a time when hemoglobin was still present? Or might they hint at a deeper, more complex metabolic strategy, one that is not yet fully understood? Beyond their biology, these creatures provoke philosophical questions about the fundamental requirements of life. Is hemoglobin truly essential? Is warm blood, a rapid metabolism, or cellular oxygen transport the universal standard? Or simply a pathway that some life forms happen to follow? Could other forms of complex life exist with entirely different biochemistries, shaped by cold, pressure, and time? Could icefish serve as an earthbound example of a broader truth, that life is not only remarkably adaptable, but endlessly inventive in its manifestations? Some scientists have speculated that the icefish's unique physiology might parallel conditions that could exist beneath the icy crusts of Europa or Enceladus, moons where oceans lie hidden, isolated from sunlight, yet warmed by tidal forces and rich in chemical complexity. If life exists in those distant oceans, might it resemble this ghost-like fish drifting through Antarctic waters? And more immediately, as Earth's climate changes and Antarctic waters warm, what will be the fate of the icefish? Their adaptations are precisely tuned to a specific environment. Even a slight increase in ocean temperature could disrupt their oxygen balance, destabilize their antifreeze proteins, or introduce competitors into a world they once exclusively inhabited. The very trait that made them exceptional, living without hemoglobin, could become their greatest vulnerability. Yet for now they persist, pale silhouettes in the deep, gliding through water as cold and dark as the vacuum of space. Their blood carries no color. Their hearts beat slowly. Their presence is subdued, yet their existence speaks volumes. They remind us that evolution is not a linear progression, that nature is not confined by our current understanding, and that even in a world of ice and darkness, life finds a way, not by resisting its environment, but by becoming something entirely novel. What else inhabits those depths, unseen, unmeasured, and just as improbable? What other biological impossibilities have adapted to flourish in silence? And as we study these clear-blooded creatures from the very edge of our understanding, we are compelled to ask ourselves, are we witnessing a mere evolutionary quirk or a blueprint for something much older and vastly more universal? From the silent movement of translucent icefish gliding through oxygen-rich darkness, we now turn our attention not to what is visible, but to what is audible, or rather, what is detectable. For in the depths of Antarctica's frozen crust, something is emitting a signal. Not in language, not in voice, but in frequency. Low, elusive, persistent. In recent years, researchers stationed across the Antarctic interior, particularly those monitoring the continent's deep subsurface, using instruments such as radio antenna arrays, magnetic field sensors, and neutrino detectors, have reported a strange phenomenon: unusual electromagnetic signals, rhythmic pulses, faint structured emissions emanating from beneath the ice, signals that, by all scientific expectation, should not be present. Some of these detections originate from deep beneath the South Pole itself. Others have been traced to regions like Piri Land, the Wilkes subglacial basin, or near buried mountain ranges such as the Gamburtsev Mountains. In every instance, the emissions are real, recorded and verified through multiple instruments, and confirmed to be of non-astronomical origin. That is to say, they are not coming from outer space. They are originating from beneath us. What then is producing these signals? The initial explanation involves the complex interaction between Earth's magnetic field and the dense conductive layers situated beneath the ice sheet. Antarctica, after all, rests upon a dynamic geological foundation. There are known volcanoes located beneath the ice, active fault zones, and even regions of high geothermal heat. And the ionosphere above the pole is constantly bombarded by solar winds, generating auroras and magnetic surges that propagate downward. However, these signals are not random. Some exhibit consistent frequency patterns. Others appear to increase and decrease in strength with no apparent correlation to solar or seismic activity. A few have been described as structured, repeating at intervals too regular to be dismissed as mere environmental noise. In some cases, they have lasted for minutes, in others, for hours. And what is most peculiar of all, some seem to exhibit movement. Detectors positioned kilometers apart have registered signals that traverse the ice in a slow, deliberate arc, suggesting a source that is in motion. But what entity moves beneath the Antarctic ice with such an electromagnetic footprint? What transmits through solid rock and frozen water with such persistence? Could it be the shifting of the ice sheets themselves, the immense, slow grinding of glacial masses against the continent's bedrock? This is a possibility. Some researchers believe the electromagnetic emissions may originate from triboelectric effects, static charges generated by the immense, slow-motion friction occurring beneath the ice. Others point to the possibility of water, subglacial lakes draining or shifting under pressure, generating piezoelectric effects as minerals are compressed and released. But none of these theories fully account for the regularity of certain signals, nor their origin points in some of the deepest, coldest, and most geologically quiescent areas of the continent. This has led to more speculative lines of inquiry. In some corners of Antarctic research, there are quiet discussions about the potential presence of vast underground cavities, voids warmed by geothermal energy, and perhaps isolated from the surface for millions of years. Could something residing within these voids be generating electromagnetic activity? In 2018, scientists with the ANITA project, the Antarctic Impulsive Transient Antenna, detected upward-moving high-energy particles that appeared to defy standard models of physics. While these are not identical to the deep EM signals, both anomalies point to a recurring theme, that Antarctica may harbor physical phenomena that we do not yet fully comprehend. And then, of course, the fringe theories emerge. Some claim these signals are artificial, emanating from something constructed deep underground. They draw connections between the locations of these signals and ancient crater-like structures or magnetic anomalies mapped decades earlier. Others go further, suggesting remnants of lost civilizations, buried technology, or the vestiges of non-human intelligence encased within the ice. There is no scientific evidence to support such claims, but their persistence reveals something more profound. A growing recognition that Antarctica's silence is not emptiness, but potential, a blank canvas where mystery still thrives. More conventional researchers are employing new technologies to delve deeper, both literally and figuratively. Networks of ultra-sensitive sensors are being deployed to monitor electromagnetic activity in real time. Ice-penetrating radar is being refined to image not just the terrain, but also the conductive properties beneath the surface. The hope is that with more data, the signals will begin to make sense. But for now, they remain a riddle. What kind of natural process could emit structured, mobile EM signals from beneath kilometers of ice? Why do some appear to repeat faintly but clearly across multiple seasons and regions? And why are they found in places where, according to all our established models, there should be nothing but frozen rock? In Antarctica, what we do not hear may be more significant than what we do. These quiet pulses from the depths do not demand attention. They hum, they whisper, they repeat. And as they traverse stone and ice, undisturbed by time or observation, one is left to ponder. Are they a signature of something ancient and still active within Earth's crust? A voice emanating from the planet itself? Or something else entirely? An intelligence we have yet to recognize, patiently reaching out in the only manner it knows how? Whatever the source, one thing is certain. Antarctica continues to communicate, and the ice continues to listen. From the quiet, drifting signals that rise from the depths of Antarctica's ice, we now descend further still into the strange and secret world that lies hidden beneath it. A world not of frozen rock, nor silent void, but of liquid, flowing, ancient, and impossibly warm. These are Antarctica's under-ice lakes, bodies of liquid water trapped beneath kilometers of ice that do not freeze. In one of the coldest places on Earth, this phenomenon seems impossible. Surface temperatures routinely plummet below 50 degrees C. And yet, beneath the immense weight of the East Antarctic ice sheet, over 400 subglacial lakes remain liquid, undisturbed by light, isolated for millions of years, and held in a delicate balance of heat and pressure. Among them, Lake Vostok stands as the largest and arguably the most enigmatic. Buried beneath nearly 4 kilometers of ice, it extends over 250 kilometers in length and represents one of the most pristine aquatic environments on Earth. Discovered in the mid-1990s through satellite altimetry and radar imaging, Lake Vostok challenged every assumption scientists held regarding the Antarctic interior. How could such a vast body of water remain unfrozen in such a hostile environment? The leading explanation involves geothermal heat. Earth's crust, even beneath Antarctica, radiates warmth, and the immense pressure exerted by the overlying ice lowers the melting point of water, allowing it to remain in a liquid state despite the freezing temperatures. Coupled with a thick, insulating shell of ice, the result is a perfect combination of physical conditions. A lake that never receives sunlight but refuses to freeze. But the mystery deepens. These lakes are not static. Some exhibit signs of active hydrological systems, connected by hidden rivers that flow between basins, transporting water and potentially life beneath the ice. Others display unusual chemistry, anomalous levels of gases like methane and nitrogen, high concentrations of salts, and traces of ancient minerals. In a few instances, organic compounds have been detected. Could life exist here in complete darkness, sustained not by sunlight, but by chemical reactions? When Lake Wilkes was successfully drilled and sampled in 2013, the findings were astonishing. Researchers discovered microbial life, alive, metabolizing, reproducing within the icy water. These were not merely dormant remnants from a bygone era. They were thriving, feeding on carbon and sulfur compounds locked within the sediments, operating within a biosphere sealed off from the atmosphere for thousands, perhaps millions of years. What else might be waiting within these hidden lakes? Lake Mercer, sampled in 2019, yielded similar results. Active microbes, unusual chemistry, and evidence of complex interactions between geological and biological processes. The microbial ecosystems here appear to function according to their own principles, shaped by slow-moving currents and underground geochemical cycles. But not all lakes have been reached. In fact, the majority remain unexplored. Some have been left completely untouched. And then there are the more peculiar features. Lake Vostok, for example, exhibits odd magnetic anomalies, regions where Earth's magnetic field behaves strangely, with concentrations located above certain parts of the lakebed. Some speculate that metallic sediments or geothermal features might be the cause. Others wonder if something more unusual lies beneath the ice. A few fringe theories, unproven but persistent, suggest that the lake may conceal long-lost evidence of ancient ecosystems, even pre-human civilizations. The near-perfect isolation, the strange geomagnetic data, and the immense difficulty in accessing it have all contributed to its mystique. A place preserved in time, untouched for millions of years. If anything had ever lived in Antarctica, when it was a green, forested continent, might traces of that life still reside within these lakes? There are logistical and ethical considerations in addressing that question. Drilling into a pristine environment carries the risk of contamination. Each attempt must balance scientific curiosity with the imperative to preserve an undisturbed system. And so, many lakes remain unexplored, not because we lack the technological capability, but because we hesitate to disrupt what may be one of Earth's last truly natural laboratories. And there is another factor. Recent satellite data and radar studies suggest that some under-ice lakes are not stable. They fluctuate in level, rising and falling, draining and refilling in sudden pulses. In 2007, NASA scientists observed the surface above one such lake drop by several meters, an indication that massive volumes of water had shifted, flowing through unseen channels beneath the ice. The scale of these movements was staggering. Billions of gallons of water moving beneath a continent that we long assumed was static. Where is this water going? And what might it be transporting with it? Could these networks of subglacial lakes and rivers constitute a kind of hidden circulatory system, connecting deep parts of the continent in ways we cannot yet perceive? Could they transport not only water, but also life or sediment, or the chemical history of an Earth that we have never truly known? And for how long have these processes been occurring? Antarctica was not always frozen. Tens of millions of years ago, it was temperate, home to ferns, dinosaurs, and forests. As the climate cooled and the ice expanded, it sealed away the past in layers of snow, then ice, then silence. But the lakes beneath may still retain that memory. They may still carry whispers of that ancient world within every drop. And so we ask, are these under-ice lakes merely scientific curiosities, products of geothermal heat and pressure? Or are they portals into Earth's deep history? And perhaps if we proceed with sufficient care and patience, might they one day offer a glimpse into forms of life, cycles of climate, or even lost epochs that we believed had been irrevocably erased? Antarctica's ice covers many things, but some of them are still in motion. Some of them still breathe, and some of them may still be waiting to be discovered. From the veiled networks of under-ice lakes where water flows in silence and time seems to stand still, we now turn to something even more volatile, something invisible, trapped not in caverns or basins, but within bubbles, sealed tightly beneath ice and sediment, confined for millennia, waiting. This is the mystery of Antarctica's subglacial methane. Deep beneath both the East and West Antarctic ice sheets, scientists have detected vast reservoirs of methane, an odorless, colorless gas with the capacity to influence the planet's climate and potentially reveal something ancient about the underlying land. These reservoirs do not announce their presence with visible plumes or surface scars. Their existence is revealed only through chemistry, subtle shifts in ice core samples, faint signatures in atmospheric readings, and the hidden language of isotope ratios. Methane is common on Earth's surface, but rarely in this particular form and never in such profound silence. Most methane on the surface originates from biological sources, microbes digesting organic material in wetlands, decomposing matter, agricultural processes, but beneath Antarctica's frozen crust, the methane is sealed away, entombed within ancient sediments, trapped in crystalline cages of ice known as clathrates, or dissolved within subglacial lakes in forms that are not yet fully understood. How did it accumulate there? Some of it may date back tens of millions of years, trapped as Antarctica transitioned from a green, forested continent to a frozen desert. When ancient wetlands and shallow seas were buried by glaciers, their organic material became sealed away. Over time, under immense pressure and microbial action, that material was converted into methane, and the advancing ice locked it in place. Other reservoirs may still be forming. In several regions of West Antarctica, particularly beneath the Wilkes and Mercer ice streams, scientists have found sediments rich in carbon and teeming with life, microbes that subsist on hydrogen, sulfur, and carbon compounds, generating methane in complete darkness. These ecosystems, isolated from the surface for hundreds of thousands of years, continue to function in the absence of light, oxygen, and seasonal cycles, and the methane they are producing is accumulating. Estimates suggest that Antarctica may contain hundreds of billions of tons of carbon trapped beneath its ice, much of it in the form of methane or its organic precursors. If released, it could accelerate global warming with startling speed. Methane is over 25 times more effective than carbon dioxide at trapping heat in the atmosphere. A large-scale release would not be a gradual process. It would constitute a tipping point. But the risk is not immediate, not yet. The ice remains thick, the pressure is stable, and the methane, for the time being, is confined within its crystalline prisons. However, the equilibrium is fragile. Climate change is already impacting the outer margins of Antarctica. As glaciers thin and ice sheets retreat, subglacial basins become warmer. Some lakes have begun to drain. Some sediments have begun to shift. The question is no longer if the methane will be released, but when, where, and how much. Yet the mystery is not solely related to climate. It also concerns life. What kind of organisms survive within these dark, pressurized systems, subsisting on rock, utilizing chemical energy, and producing methane in complete isolation? Some of the microbes recovered from drilling samples in Antarctica share similarities with extremophiles found at deep-sea hydrothermal vents and beneath the Arctic permafrost. But others are more unusual, genetically distinct, metabolically novel. They may represent ancient branches of life's evolutionary tree, survivors of Earth's early biosphere, flourishing in environments that mimic the planet's distant past. Could they serve as analogs for life on other icy worlds, Mars, Europa, Enceladus? If methane is currently being produced in the darkness beneath Antarctica, what might that imply about methane detected on Mars, where plumes appear and vanish in cycles that we do not yet understand? And then deeper still lies the question of methane's origin. Not all of it is biological. Some methane may form abiogenically, produced by chemical reactions between water and rock deep within Earth's crust. These processes point to geothermal forces, tectonic heat, and interactions that are still active beneath Antarctica's ice. Could a portion of the methane signature indicate geological activity that we have not yet mapped? Could shifting reservoirs of gas be a sign of deeper forces at work? In certain regions, magnetic and gravitational anomalies coincide curiously well with suspected methane sites. Some propose a connection between geothermal heat, crustal structure, and gas migration. Others point to the possibility of unknown volcanic activity or the remnants of ancient hydrocarbon systems now buried in silence. And then, of course, there are the more speculative questions. Could the methane reservoirs hold more than just gas? Could they preserve ancient DNA, fragments of life from a time before the ice? Could they conceal microorganisms with metabolic pathways never before observed, or chemical signatures that necessitate a revision of our understanding of the deep biosphere? Thus far, we have only metaphorically scratched the surface, and literally in a few specific locations. Most methane deposits remain sealed, undisturbed beneath kilometers of ice. Sampling them is a delicate procedure. One misstep, and a release could contaminate both the existing ecosystem and the scientific data. And so we wait. We monitor, we model, we imagine. Because these reservoirs are not merely a potential threat, they represent a message from the Earth itself, a record of ancient climate, ancient life, and ancient carbon held in suspension. What will be the consequences if that record is disrupted? What might we learn from what escapes? And what, still sealed in the cold, remains hidden, waiting to be discovered not through fire or flood, but through a breath of invisible gas rising one day from beneath the ice? The ice remembers, the pressure holds, but the Earth even here is alive. From the silent pressure of methane sealed beneath layers of ice and time, we now direct our attention to something smaller, quieter, and infinitely more ancient. Not a gas, nor a signal, but life itself, or what may endure of it. Frozen deep within Antarctica's ancient ice, embedded within layers compacted over geological epochs, scientists have made a remarkable discovery. Tiny structures, fragile fragments, microscopic organisms preserved in a state of suspended animation for potentially up to 500 million years. 500 million. These represent the strange remnants, or perhaps the dormant echoes, of ancient life forms found in the deepest sections of Antarctic ice cores. Extracted with meticulous care from depths exceeding 3,000 meters, these cores are more than mere cylinders of frozen water. They are scrolls of Earth's past. Each layer serves as a page recording atmospheric changes, climate shifts, volcanic eruptions, and occasionally the faint traces of life that once drifted through ancient skies or inhabited long-vanished seas. Among these traces are simple microbial forms, cyanobacteria, diatoms, spores, and in some cases even cellular structures whose origins extend back to the Cambrian period, more than 500 million years ago, when complex life on Earth was just beginning its proliferation. How did they arrive here? Some may have been transported by wind, dust particles carried into the stratosphere and deposited over Antarctica during ancient global events such as volcanic eruptions, meteorite impacts, or massive climate shifts. Others may have originated from below, caught in upward flows through fissures in the ice, remnants of deeply buried ecosystems now erased from the surface. However, their preservation raises more profound questions. These microorganisms are not fossilized. In many instances, their structures remain intact. Membranes, pigments, and even DNA. Fragmented, yes, but present. Some researchers theorize that they may not be entirely deceased, that under suitable conditions they might reawaken, reanimate, and undergo cell division. Could they still be viable, locked in a state of metabolic dormancy for hundreds of millions of years? In 2000, a team of scientists successfully revived bacteria from an ice core estimated to be over 120,000 years old. Subsequent studies extended that timeline further, reviving spores from permafrost and glacier ice dating back over 750,000 years. These ancient microbes resume growth when exposed to warmth, nutrients, and moisture. If such extraordinary resilience is possible in known extremophiles, what might be true for the enigmatic organisms discovered in even deeper layers? And what if some of these life forms are unlike anything we have ever encountered? Certain samples have yielded microfossils that resist classification, structures that do not resemble any known bacteria or algae, unusual lipid compositions, peculiar genetic sequences. Could they represent extinct lineages, ancient domains of life that did not survive into the present era? Or perhaps they are ancestors of modern microbes, frozen at a pivotal juncture in evolutionary history, suspended just as biological complexity was beginning to take hold. The implications of these findings are staggering. These organisms offer more than just a glimpse into ancient biology. They are a time capsule, one that spans major mass extinctions, significant tectonic upheaval, and even the genesis of modern ecosystems. Studying them may reveal crucial information about Earth's early atmosphere, its primitive oceans, and the delicate ecological balance that facilitated the emergence of life. But there is another, more speculative layer to this mystery. If life can survive for hundreds of millions of years, dormant, hidden in ice, what does that imply for other frozen worlds? Mars once harbored water. Europa and Enceladus still possess subsurface oceans. Could similar microscopic life exist there, waiting beneath icy crusts in dormant silence? Could organisms from Earth's Cambrian oceans bear a resemblance to life that might exist or once existed on those distant moons? In fact, the parallels are more than poetic. Antarctica, in many respects, serves as Earth's closest analog to these icy worlds, and its ice cores provide our initial and most valuable insight into what transpires when life encounters deep geological time. However, not everyone agrees on the interpretation of these findings. Some scientists advocate for caution. Contamination is an ever-present risk. Handling ancient ice cores without introducing modern biological material is notoriously challenging. Are we truly studying Earth's distant past, or are we inadvertently examining ourselves? Are the anomalies genuine, or are they artifacts introduced by the tools and methods used to discover them? Even among those who accept the findings, debate exists. Some argue that the organisms are relics from shallow seas that once covered parts of Antarctica before the ice came. Others suggest they were deposited from the upper atmosphere during turbulent ancient epochs. A few speculate that subglacial lakes, isolated for tens of millions of years, might harbor still-living communities from which these ancient microbes have somehow escaped. And then there are the deeper, more unsettling questions. Could these organisms, dormant for eons, possess genetic traits unknown to modern biology? Could they interact with modern ecosystems in ways we can't predict? And are we adequately prepared for the potential consequences if, in our pursuit of knowledge, we inadvertently awaken something that was intended to remain dormant? No one possesses definitive answers. For now, the organisms remain under rigorous study, maintained in sealed laboratories, examined under microscopes, sequenced and scanned. Most show no signs of activity, but even in their inanimate state, they communicate. They speak of a world we have never witnessed, a time when continents were still shifting into position, when life's grand experiment was just commencing. And yet they are here, beneath our feet, preserved within ice so clear it appears like glass, murmuring of oceans that no longer exist, skies that once held a different atmosphere, and creatures that have long since faded into the dust of time. What else lies locked within that ice? What other histories remain unread? And when we finally reach the oldest layers, the deepest cores, will we uncover not merely evidence of life, but something far more intricate, something that still awaits its name?